হ্যালো প্রণব, শুনতে পাচ্ছ? হ্যালো 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 প্রণব, শুনতে পাচ্ছ? আনমিউট করেনি প্রণব। শুনতে পাচ্ছিস না? তুই একবার বলবি তো অনলাইনে, আমি চেঁচিয়ে যাচ্ছি হ্যালো হ্যালো করে। ঠিক আছে, ওকে ওকে, শুনতে পা ঠিক আছে ঠিক আছে ঠিক আছে। ওকে, স্ক্রিনটা এখনো শেয়ার করা থাক, আমি বললে অফ করবি। ঠিক আছে। আচ্ছা, স্ক্রিন শেয়ার করা থাকলেও তো আমি ইয়ে করতে পারবো তো, আপডেট করতে পারবো তো প্যানেলিস্টে। হ্যাঁ, সরি সরি। সুমনা, ক্যান ইউ হিয়ার মি? শুনতে পাচ্ছিস?
Yes, I can hear
ওকে
you.
ওকে ওকে ওকে, ফাইন।
Okay, give me the permission to share my screens. I will be going back and forth with screen sharing.
You will share after we will start and give the academic portion of yours. Then we will you can share. Now actually I have shared it.
So you can give the option of multiple people, so you don't need to change every time.
Okay.
See there is a screen sharing. You can just click the button. Multiple people can share the screen.
Multiple people, all panelists who can share. All panelists, I have kept it in all panelists. Who
It's
can
fine.
start sharing when someone else is sharing? Okay, I have to tell all panelists. Yes. No problem. Okay, I've done it. It is actually 6:50 now. We will start sharp at 10. Okay. Okay. Okay.
Hello, Papia. Hello. Hello. Can you hear me? Hello. Can you hear me? Okay, thank you. But my
রনেনদা ঠিক আছে? ঠিক আছে, সুমনাও জয়েন করেছে। আমি আর 1 মিনিট অপেক্ষা করছি শ্বেতাদির জয়েন করার জন্য।
Okay.
Then we will start, okay?
Okay.
শ্বেতাদি এখানে জয়েন করবে, হ্যাঁ, প্যানেলিস্ট করতে হবে। এটা একটুখানি খেয়াল রাখছেন, এটা গ্যালারি ভিউ, গো ফর গ্যালারি ভিউ। শ্বেতা অফ আছে, সাউন্ড অফ আছে, নিজে ভিডিওটা অফ করো, পরে অন করো।
আচ্ছা, তুই দরজা ভেতরে চলে যা, আমি বেরিয়েছি।
Shumana, let me informally introduce Ronenda with you. I am not starting formally. Ronenda, Professor Ronen Bhattacharya, he is the senior most faculty of the Department of Mathematics in our institution. He is also very popular teacher and he is also the governing body member of our institution. So Ronenda is here.
Thank you.
And Shumana is my friend, childhood friend. And now, as you all know, that she is the Associate Professor, Department of Mathematics, Clarkson University, USA. I am going to introduce her formally a little bit later. It is exactly
Thank you,
7
madam.
already.
Nice to meet you. Call me Shumona. Call me Shumona.
Okay,
I'll call you Ronenda.
Ronenda is very popular teacher and he is the writer of many textbooks. প্রচুর বই আছে রনেন্দার, ভীষণ ভালো পড়ায়।
বাহ।
না, আমি মূলত হচ্ছে অ্যানালিসিস বা অ্যালজেব্রার লোক। হ্যাঁ, ম্যাথমেটিক্স। আপনার সাবজেক্ট কি?
তুমি
আমার
বলো, তুমি বলো,
স্ট্যাটিস্টিক্স। আচ্ছা আচ্ছা।
বলতে পারো, সুমনাকে বলতে পারো, ও সেটা at least
না, আমি খুব একটা কিছু জানি না সত্যি সত্যি, কারণ আমার তো ব্যাচেলার্স মাস্টার্স সবই স্ট্যাটিস্টিক্স এ ক্যালকাটা ইউনিভার্সিটি থেকে।
আচ্ছা আচ্ছা।
আমি ম্যাথ খুব কমই পড়েছি, ওই যতটুকু দরকার আর কি স্ট্যাট পড়তে গেলে।
হ্যাঁ হ্যাঁ।
আমাদের অলরেডি 170 জন হয়ে গেছে। আমি একটুখানি ইনফরমালি বলে নিচ্ছি যে আমাদের প্রত্যেকদিন, এই তো শ্বেতাদি এসে গেছে, রাইট? ওকে, শ্বেতাদি ইজ হিয়ার। প্রথমে আমি একটু ইনফরমালি শ্বেতাদির সাথে সুমনা তোর পরিচয় করিয়ে নি, ফর্মালি করছি। ডক্টর শ্বেতা গুহ, উনি হচ্ছেন আমাদের কলেজের IQSC কোঅর্ডিনেটর, মানে আমাদের এখানকার ইনস্টিটিউশনের ইন্টারনাল কোয়ালিটি অ্যাসিওরেন্স সেল। ঠিক আছে, এটা হচ্ছে প্রচন্ড একটা ভারী বডি, যাকে আর কি কলেজের সমস্ত অ্যাক্টিভিটি মনিটর করতে হয়। শ্বেতাদি হচ্ছে তার কোঅর্ডিনেটর, মানে দিস কাইন্ড অফ প্রোগ্রাম কি হবে না হবে আইডিয়া গুলো শ্বেতাদিকে সবসময় মানে মনিটর করতে হয়, এবং তার উপর কলেজের অ্যাসেসমেন্ট ডিপেন্ড করে, মানে শি হ্যাজ টু প্রডিউস লট অফ রিপোর্টস এন্ড এভরিথিং, তার উপর ফান্ড এন্ড অ্যাক্রেডিটেশন, যেটা আমি আলোচনা করেছিলাম তোর সাথে।
মানে খুব রেসপন্সিবল একটা পজিশন আর কি, প্রচুর কাজ থাকে,
প্রচন্ড ঝামেলার, প্রচন্ড
ঝামেলার পোস্ট,
সেই ঝামেলার পোস্ট, বুঝতেই পারছি।
So I think now we can start formally. Now we think we can start formally, so I'm starting recording. So a very good evening to everybody, participants and all the faculties and dignitaries over the screen. I really welcome you in the 7th day of our International Student Development Program, which is running really successfully with the overwhelming response from the students. Each and every day, approximately 200 to 210 students are regularly attending in Zoom, and 30 to 32 students are regularly attending in YouTube. Before today, our resource person is Dr. Sumona Mondal. I would like to introduce Shumana. In the inaugural session also, Shumana was present, but that day I just introduced her as our collaborator, overseas collaborator, associate professor, Clarkson University. Since she is the resource person today, I am going to give a very brief academic introduction of Shumana. Shumana has completed her bachelor's and master's from the University of Calcutta. Then she completed MS from Louisiana, University of Louisiana at Lafayette, LA. Then she completed her PhD in 2007, also from University of Louisiana at Lafayette, USA, LA, Los Angeles. Then she was in different position. I would like to mention, she was initially the system engineer, ADS Software and Services Private Limited, Calcutta. She was also statistical consultant, Indian Statistical Institute, Calcutta. She was graduate teaching assistant, University of Louisiana at Lafayette, LA. And finally, from 2007 onwards, she was assistant professor, and now she is the associate professor in the Department of Mathematics, Clarkson University. She is the reviewer of several reputed journals like IIE Transactions, AIMS Journals, etc. She had received a lot of awards, out of which I would like to mention Graduate Teaching Assistantship, University of Louisiana at Lafayette, Rhodes Outstanding Teaching Assistant Award from Mathematics Department, University of Louisiana, NSF Travel Grant twice, recipient of Clarkson University Students Association Outstanding Teaching Award, Clarkson Ignite Research Collaboration Pilot Grant Program Award, a lot of award. She is really, really a good teacher, you can understand. She had a lot of contribution in terms of publication, more than 13 international publication, which includes a lot of reputed journal. I would like to mention journal like PLOS
I'm not going to the details. It will take a long time. She has now, she is actually the principal investigator of 2 major projects which is running in her university, and completed 7 major research project over there. She had many other synergistic activities, out of which I would like to mention 1 or 2 with you. She had developed and involved in Clarkson University Data Analytics Master's Program. She developed new courses at graduate level, probability and statistics for analytic and data mining and statistical decision making for the data analytics program jointly with David D. REH School of Business. Developed new course introductory biostatistics jointly with biology department. Developed 2 1-credit seminars for undergraduate biomath students, and conducted a short course in basic statistics at RIKEN BSI Japan. So she is basically a student lover. You can understand. That's why I just requested her, rather I must not say requested. I just tell her that please do a program with us, and we are also planning for some future venture, and she just tell okay, no problem, because you can understand from the awards and whatever she has introduced in the University of Clarkson. So Shumana, formally I am very much thankful to you. And now, before you start your program, I would like to invite, or I would like to request our senior IQSC coordinator and our senior faculty member to tell a few words about it. Shwetadi was actually absent in the last day. She was burdened with a lot of work. That's why it was not possible for her to come to the inaugural session. So first I would like Shwetadi, please tell a few words about this.
Thank you, Papia, and really congratulations for organizing this unique program that is first time in our college. And my sincere thanks to Madam Sumona Mondal for being with us for this wonderful collaboration. And I hope our students are really enjoying this program. And I heard that the program is running very successfully. And I hope you will be with us in near future too. Thank you, madam, and all the best, Papia, and all the mentors. Thank you all. Thank you, Papia.
Sorry for the interruption. Actually, Rupak has already joined, and I am just promoting him as one of the co-hosts. Just 1 minute, please. Just 1 minute. In between, I would request Professor Ronen Bhattacharya to tell a few words kindly, because he is from the Department of Mathematics, and Shumana will obviously like to hear something from him, I think.
Thank you, Papia. I feel I am very much fortunate that I have been asked to say a few words in this great program on advanced learning and career guidance organized by IQSC department, IQSC and Department of Zoology, Vijay Krishna Girls College, in association with Clarkson University, United States, and Cytogenics and Genomics Research Institute, Department of Zoology, University of Calcutta. So I would, this program is very impressive. I think our students and all participants, including our students, will be enriched themselves, will be by these eminent speakers who have joined this program till date or are to join this program. For today's program, I would like to thank Dr. Sumona Mondal, although she has given me permission of calling her Sumona. Anyway.
Absolutely. I'm not used to hearing ma'am or anything, just my name, first name.
Thank you, Shumana. So I am a member of governing body of this college, and on behalf of governing body of this college, I would like to request you, and on behalf of Department of Mathematics also, I would like to request you to make such arrangement with other departments also. If you consider the feasibility or possibility to make such arrangements, such thing with what is going on to other departments of our college. So I don't want to waste much more time. So I am returning this microphone to Dr. Papia Ghosh. Thank you. All the best.
Thank you, Ranenda. And Shumana, I would like to introduce you with Dr. Rupak Bhattacharya. He
Hello,
is
madam.
faculty of Department of Mathematics, but he is also the head of computer science of our college. And I must tell you that he is also a very promising scholar. Okay, she is very promising scholar, and she has also publication in reputed journals and still continuing a lot of research. So Department of Mathematics and Computer Science along with you will obviously in future like some kind of collaboration that we will discuss later. So thank you, Shumana. And Rupak, would you like to tell one or two words particularly now? I would like to request you to tell one or two lines about this program or whatever your feelings right now.
Thank you, Bapiyadi, and thanks for the compliments. Shumana madam, this is means a great.
Well, you can call me Shumana Di if you are calling Papia Papia Di.
Yeah.
Okay, I'm obliged, Shumana Di. So, Department of Computer Science and Department of Mathematics, both are very old departments of our college, and most of the faculty members and also the students are research energetic, I would say. I cannot say research involved in a for students of an UG college. So for future collaboration, that would be great. Even I am interested to do some work in your field. I talked with Papiadi already. So
very good.
Thank you.
We will keep the conversation going.
Yeah, thank you, Didi.
Okay, thank you, everybody. Thank you, Shetadi, Ranenda, Rupak, definitely. And we are obviously organizer. And Shumanake, I'm not going to give thanks. She is my childhood friend. And one more informal thing I would like to just share at the beginning. She was throughout first girl up to class 10. We were together.
No, not true.
No. I want to share. We were very best friend. And I used to secure second or third position. Though we were very, very good friend. We were four there, very good friend. But I always want to beat her that I will get the first position. But due to her excellence in mathematics, it was impossible for me to beat her actually. But she is really, we were very good friends. Not only classmates, but we were best friends. We four were.
Well, you can see it's more than 35. Yeah, it's more than 35, 36 years we are friends. So you can see nothing can beat our friendship. Okay. Yeah.
Okay, so now it's over to Shumana. Shumana, please continue. We have already 200 participant students over here and 32 in YouTube. That is the usual attendance over here. Most of them are UG, some of them are PG. So it's on to you. Thank you, everybody. Okay, so I am shutting my video and I'm muting myself. Okay, thank you.
Thank you, everybody, and special thanks to all the audience. Generally, I like to interact a lot in my class lectures, but due to the limitation of this online and limitation of the time, probably we will keep our conversation going later after the talk. But I am very much interested to keep interacting with you guys in future. Just to give you a background, Papia, thank you so much. It was not a request, it was a comment from Papia, and I accept that. Whatever she asked, I will do. That's for sure, even Shujoy also. And also thanks to Ranenda, thanks to Rupak. It was really nice to get introduced with you, and I hope that our conversation will continue. Give you a brief background of Clarkson University. We are a small private school. I think it's our interest is definitely focused on research, and we are located at the northern part of the New York State, which is popularly called upstate New York. There are 3 schools in our university. We call it School of Arts and Sciences, School of Business, and School of Engineering. So our math department belongs to the School of Arts and Sciences, where all other basic sciences are taught and the research programs are there. Most of our schools, the departments they are consisting of, have the PhD program. That means we are kind of research focused quite a lot. We have around 32 to 3,300 undergraduate students, and then we have around like 500 to 600 graduate students and postdoc. Across the discipline, the research and collaboration are very much appreciated and encouraged. And like as a statistician, I collaborate with a lot of different faculty in different schools. Another interesting thing, in most of the US schools, sports are very much encouraged. Just I like to highlight that in last 6 years, and 1 programming language R. I'm going to show you with the software because that is easy, but all the details are in my slides, which I'm going to share right after my talk with Papia, and she can put it in the website or wherever you can get access for the data, the results, all the graphs, and all my slides. So I'm going to start sharing my screen, and please stop me if there is any technical difficulty or if there is something that is totally not understandable. I sometimes go really fast, I sometimes go slow. So according to the speed you want, I can manage, or I can manage my acceleration. Please let me know. Don't hesitate to ask me to slow down or to go fast. So I'm going to start sharing my screen with the topics that I'm going to cover. So I believe all of you can see my screen. I will need sometimes yes or no, maybe from the panelist. If you can just say yes, no, that will be. Absolutely. Thank you. So as you see from the first slide, it is just basic statistical concepts, and they are developed for biostatistics students. I teach an introductory biostatistics course at Clarkson for last 7-8 years. And we always have graduate students to help us in grading, in helping the course material. So for this particular development of the slides and other details, I have one of my graduate student, Dinushani Senaratna, who helped me, and we definitely like to acknowledge our student. So she is one of the PhD student from Sri Lanka in the math department, and she helps me in my biostatistics course preparation. So we just start with basic statistical concept and related test. Now, what is important in statistics that we all know, and I'm not going to details of reading the slides. Statistics is a branch of mathematics that actually helps in collecting, analyzing, interpreting, and presenting the numerical and categorical data. So we have to be very careful about the types of data that we deal with. Now, this is a part of mathematics, which I really don't like to hear all the time. I think that statistics is a separate, distinct discipline, which is true, but we cannot deny the fact that it is the part of applied mathematics, which is getting its importance and popularity on its own. And Arnav raised hand. Anything, Arnav? Okay. Yeah, you can put all in the chat box. I will take that. Maybe I can give a break in between. We can take some questions over there. Yeah. So then why we need statistical analysis? Probably you all bio-related or bio majors know more than me that every day, every minute, every second, we produce data. And to understand what the data is telling us, we need some analytical method to understand that most importantly. And that's what we need, the statistical analysis. And that's the reason that there are so many different even categories of statistical analysis that are getting prominence every day. Now, what we need to know at the beginning or as the starting point, the description of the data and the inference that relates to that data, which will give us the idea what to do next, how to collect the data most efficiently, what are the things that we can understand from the data. So these are the things that we should know at the beginning of our data analysis. And that's what we need to know, the descriptive statistics and simple statistical inference to go with. Now, there are few things that Papia has mentioned to focus for this particular workshop. This is again just a very brief subset of the whole thing that we do in a basic biostatistics course. In basic biostatistics course or a statistics course, what we need to know at the beginning is the concept of probability and its distribution, because every concept in statistics is depending on the probability, what means like how the data is developed from a function and how we can make that function tells us the truth behind it. And there are lots of developed theories based on the type of the functions which are actually helpful, and there are techniques developed for that which can be used. So what I'm going to do today sequentially, first give you basic idea about descriptive statistics. What is the minimum that we should do for any data to be analyzed? Then we want to see in the data analysis, the descriptive statistics that will follow up if we need to find the correlation between variables. It could be correlation between two variables or more than two variables. Then we deal with quantitative data. At the same time, qualitative data or categorical data are very much important, and a lot of time we just ignore the fact how to deal with that categorical data. Goodness of fit test or the basic goodness of fit test is one way of dealing with that, and we are going to check with a simple example how to get through that. Then we are going to come to the most, I will say, the most widely used test in the biological field that statistics has even seen are two of them. One is independent unpaired t-test and dependent or paired t-test. Along with that, that goes the analysis of variance technique, which is the extension of these two tests, which we are not going to discuss today, but these are the three basic tests which are used extensively in the literature of biology or biological literature, and they give us a very good meaning of the data. To start with, what we know about the description of the data. Now, any data set, when we get, be it like 5 variables, 6 variables, 7 variables, 1 million variables or whatnot, we want to see each and every variable separately, how that is behaving. And it's very important as a data scientist or a data analyst to look at. What we want to see from there, we want to see these basic few things: maximum, minimum, mean, median, mode, first quartile, third quartile, second quartile, which is same as median, interquartile range. These few things will tell us the distribution of the data in a very nice way that will lead us to the next step. What should we do? How to deal with that? Okay, let me go through my data set. So I have, one second. Okay, can you see my Excel screen? Just one person say yes or no.
Yes, yes, yes.
Okay, so we can see there is a data set. this is the data that I get most of the time from my collaborators, and I ask them to send me the data through Excel or CSV file. You can see there are a few variables that are going. One is person, that is the ID of the person. Not that all the persons are taken into consideration for this analysis, but we have to give a unique ID to each person, and that is de-identified. So we don't know who that person is. It's just a number for us when we analyze the data as a data scientist. We can see the gender of that person is given. So 0 means probably male or female, 1 means the other person, other category. Then we are given the age, then the height. Then we have 3 other variables. One is the weight before, then they were given some kind of diet, and after the diet was given, their weight was calculated again or weighed again, and that's the number. So what we see, there are few variables for each person they are given. And if I ask you what is the data set, each row is a data point. Each row for us is a data point. Say the person number 37 has a gender, has an age, has a height, has a weight before the diet was given. Then that person was given the diet number 2. And after that, the weight was again checked, and I can see the weight is reduced. So something diet plan that is going on for that person. So when we are given this data, before even we know the hypothesis, what we want to do with the data, or if you know that also, we want to see how each and every variable is distributed or actually collected. For example, suppose I want to see a weight reduction plan from the diet that is under consideration for the data. I really want to see the gender distribution was done fairly. I will not get a data where there are out of 100 persons, just 20 were female and 80 were male. Then I cannot say much about that diet plan because the distribution was not good. How do I know that? I'm going to check with the gender. Age, I would like to see if the diet plan, whoever is doing that, they are concentrating on the people who are aged 50 years or less, or who are aged 30 years or more. If they know that fact, I'm fine. But if they are distributing the age evenly over the population, then there should be a representation of each age group in my data. How do I know that? I'm going to check with my analysis. Height, there should not be any kind of outliers in my height. I know that height is distributed somewhat like normally, and I know that you already have learned a little bit of the normal distribution or the Gaussian distribution. That means we can see there are always less people with low heights, less people with very high height, but most of the height distribution is concentrated in the between. Similarly, weight should be like that, and the diet plan that is given, I'm expecting that the experimenter has distributed the diet plans evenly to the subjects so that they want to see which diet plan is performing the best. I can see that only if I do look at each and every individual variable very accurately. There are certain variables, if I look at here, they are continuous variables, or we call it numerical variable, and some of them are categorical variable. We have all idea about those things. Very importantly here, if you see, gender is a dichotomous variable or a binary variable or a categorical variable, because there are 2 of them are considered male and female. Age, height, before weight and after weight, they are all kind of continuous variables, and diet plans, that is a categorical variable. Categorical variable can also be of different kinds depending on the nature of their. Here, diet plans 1, 2, 3 is just a number. So they don't mean anything based on the number. I can call this diet plan as 1, or I can call this diet plan as 2. It really, the experimenter who decides what I'm going to call that. 1, 2, 3 does not mean anything rank wise. At the same time, there are categorical variable which are actually ordinal in nature. What it means, they have a meaning from the number they are given. For example, suppose I want to see all of your grades, and I give you like grades of A, B, C, D. Here A means some things, B means something, and C means something. So there, these are all categorical variable. At the same time, A, B, C, D has different meanings. So we have to be very careful about this kind of situation before we start analyzing the data. And then we have the after weight, which is a continuous variable. What we do with the data? First thing, we just want to play with the data, see different things, what we have in the data. For that, we need a software. And in biological research, what we have at Clarkson, there are few softwares which are very user-friendly and extremely powerful, getting, I believe, getting powerful each and every year because they have to compete with each other. And they give us all the necessary tools that we need to analyze this kind of data. I'm using one of them that is called Minitab. And this Minitab, what we do here, let me just see if I share this. Okay, can you see another screen with Minitab dataset 1? Yes.
Histogram of
So
age.
what I did, I just copied that Excel file here and I just have the data here. You really don't need to do much. I bring this file here, I have all the data. It can handle actually many rows. And generally, if it is too many data set, we really don't go with this kind of software, but the type and the nature of data that we deal with every day, it's perfect. And you see each and every button on the top, they tell a lot. Lot means a lot. Even if I just click the button stat, okay, I'm just clicking it for you. If you look at the buttons that is there, these are the courses that I had to take. Each of them is a course that I had to take during my graduate study, PhD study, like basic statistics, regression, analysis of variance, design of experiments, quality tools, reliability, predictive analytics. These are basically a 6 months, or I will say 4 months long course. That's what they're giving you these buttons, and they are extremely powerful in understanding the data. Now, if I go back, I'll come back to here. I'll go to the slide one more time. If I go there, so what I just said, I want to know the descriptive statistics of all the variables that I'm talking about, maximum, minimum, mean. I will just do one click and it will give me the idea about the data. And what I had given the description of the data I just stopped here. Here is just a snapshot of the data that I put in the slide so that when you follow later, you can see what it means. I categorized each of them. Gender, this is a categorical variable where 0 means the female, 1 means the male. Then age, each person's age, is a continuous variable. Then height is a continuous variable with each person's height. And so all these description are given here. So next, what we want to do, we want to go to the software and try to see how we can deal with that. I'm showing you right now, it is all written here, so you can follow it very easily later when you try to understand. And this software actually is, I will not say it's really cheap, but at the same time, they have the option for students to download for a month for free. If you really want to play with them and see that they are very useful, you can download in your PC or Mac for a month for free and play with that. And most of the times, actually all the time, during my PhD also, and even at Clarkson, I see university buys this software and they kind of install it in a computer lab or some computers in the school where you can go and get your data and analyze and come back. You really don't need to use the software like 24 hours. You just need to get your data clean and precise, go to the computer where this software is installed, then just use the software, get your graphs, get your analysis, and just bring back the results. That's good enough. But again, if you want to really get it, there are options for the students. You can rent it for really low price, or you can buy it even the I will say kind of a minimized version in a cheap price. But as I say, every university has. Even in 2000, when I was graduating from Calcutta University, they had SPSS installed in all the computers labs in the statistics department at Baligan Science College. So I can expect that the system is still going. The version that I'm using is the latest version of Minitab, which is version number 19. And the SPSS that I'm talking, the latest version is 25. So let's see, go back to the Minitab, how I'm going to deal with that and produce some results which is meaningful. To do that, I'm going to the SPSS again, and this is what is my SPSS. As I said, we know all the variables now. I just want to play with first age. So let's do what we can do for the age. When I want to do anything with the age, I go to stat, or I can start with even graphing. Okay, let's start with graphing. So I want to do a simple histogram of the data. So I click this button, histogram, and then once I click that, they are going to give me several options. Which one I need? I just need a simple one. So I click the simple, go to OK. Then I already have height here. I'll just take this off. I can see in this box, all the variables they are given in the data will pop up in the leftmost box. What I want right now is age. So I'm going to double click that, or okay, not the height. I want the age first. So I'm going to double click age, that will come here. I can have all the variables at the same time coming in this graphing variables and see that, but I want to see one at a time. And I really don't want buttons here. Learn more, or we want to learn more, you can check with that. Very simple histogram I want to see for the data. I just click OK. And the way they give you the result, that will come exactly this way. So if you just look at this histogram of age, I can see kind of normal. Most of the ages are in between. And if I see the numbers, the range I can see from somewhere like, I believe like, I don't know, 10, 15 or something to going to 65, 70. So I don't know the numbers, but I can see the pattern of the data, particularly for the age, how it is behaving. Now I want to get to the description of the data so that I know what's going on. Very simple again. I go to stat. I go to just click basic statistics, very, very basic statistics. I go display descriptive statistics, click there. And I already have done it for all the variables. I'll take it off. I'm just going to see for the age. So I double click here. And then if I click this button statistics, it actually gives me the options. Generally, I have all my options already clicked here. You can click, unclick the way you want. There are all of them. Say I want the range as well. So I'm going to click that. I don't need trimmed mean. I just need mean, standard error, standard deviation, variance, first quartile, the basic ones that I have given. You can do skewness, kurtosis, everything that you really need. I'm going to click OK and just click OK. You will see everything is here coming one at a shot. I can see the total numbers. There are mean, this n star means no data was missing. So these are the very simple and effective way of looking at the data. Here, there are just 78 observations. It's easy. But if you have 780 observation or 7,800 observation or 78,000 observations, it is just one click. And that gives me the various results in the nicest way I can see. The variance is quite high. So that means the data have really good fluctuation. The minimum I can see as 16 years and the maximum is 60 years, where I can see the Q1, Q2, Q3. I believe everybody knows what it means by Q1, Q2, Q3. I'm going to come to that a little bit, but we all know what it means. And then we can get all the data set in the nicest possible way we can think about. I want to graph one more thing that is very important, and we do that for almost all the continuous variables these days to see how the pattern is, which is a box plot. A box plot is something that shows the distribution of the data in a nicest way, where the Q1, Q3, and Q1, Q2, and Q3 are noted. At the same time, the distribution pattern or the variability is noted. Whereas if there is an outlying observation in the data set, that is also given. To do that, I go to graph. Again, I just click the box plot option. You can see there are so many options. If you just click graph, scatter plot, matrix plot, bubble plot, You can play with all of them, and any software, when you learn, there is a help button to understand how these are done. And also everything is in the internet. If you want to learn, just Google scatterplot Minitab. This will show you everything that you want to know about the scatterplot, how it is done in Minitab. So I go to simple box plot. Again, you see there are so many of them. Now it becomes very important when you have age. Here I have the age for just one particular group. Suppose my study requires the age distribution of the male and female. Okay, I have them separately in separate columns, and I want to do two box plots separately. So there are options that you can do the box plot with groups. That's what these softwares are extremely useful to understand what's going on. Or even suppose you have a biological experiments going on where you have three types of, say, Drosophila. I'm going to make a lot of mistakes in saying all these biological terms. Please correct me if I'm wrong. Suppose you have three species of Drosophila and you want to see their one particular variable, how it is distributed. You want to compare them side by side, and you have taken the data initially, then you need to do the simple dot this plot, box plot, side by side, not just one at a time. And you can do that. You just need to kind of manipulate the data, put it in the right format. For us, we just have one variable, simple. I just click OK, and I'm going to bring my age variable here. If I do that, this is what I can see. So what I see here, it's a very nice data actually, no problem with the data set, where I can have no outlying observations, and then whatsoever I have the median kind of close to 38 years of age, then the Q3, Q1, they are distributed evenly. Now, just for the sake of understanding, suppose I am changing two of the numbers. Okay, this is suppose a mistake, and we all make mistakes likewise. Suppose I'm just changing the age for the few. I just make a mistake of getting the data wrong. I'm just going to change it to 5 and 7, just like that. Okay, I just made this mistake, and then I want to draw the same plot and see what we get. I go to graph, then again I go to box plot, simple, age again, click OK. So let's see what we have now. There will be a lot of changes. Can you see the changes? We see two stars here, which actually is telling me there are two outliers, which I made it intentionally. And that is from the Pearson 37, for that the age is given as 5, and the Pearson 31, for that person the age is given as 7. So I can see those two data points are really making my data set looking bad. And I can see it just by looking at this plot. So plotting them, understanding them is very important. If I click my simple statistics with the basic statistics I just had, display descriptive statistics age now, you will see a lot of changes in the data set. The numbers are totally now very different than what we had before. And how we know that? Because we can use the software and we can see how the data is behaving. Similarly, if I want to go for the next part of the lecture, let's see. We just learned about age, as we have seen. Then we can go to the height of the person. Then we can go to the, you can play with each and every part of the variable. Let's see height. I think height has a little bit different ways of distributing that. And then after the height, we have the categorical variable, that is the male and female, which is the gender. So let's go to the height variable just to see what's going on over there. So let me share again this. Okay, now we are back to the Minitab software, and we wanted to see how the height was behaving. So if I just graph very simplistic way the histogram for the height now, I take off age, just go with the height. Okay. So there are certain things in the height. Of course, most of them are distributed nicely in the middle, but there are quite a few heights which are very high, and there are one or two probably pretty low. So we can see from this histogram what's going on. By the way, if you really want to put this histogram in your Word file, in your report, you can do a lot of changes over here. You can double click this, it will come like here. You can change the name on this level of y-axis. You can change the level for the x-axis. They are very easy to be done in this kind of software, and you can actually either you can copy the graph, paste, or you can export. There are a lot of options. You can actually change the graph and bring it to your report where you want to produce this kind of graph. These are all available for all these softwares. So we can see the height in a graphical way. If we want to just play with the basic statistics here, display descriptive statistics, I go to height, and that tells me, well, I have a minimum of 141 and a maximum of 201. I have the range at 60, then Q3. By the way, what we mean by Q1, Q2, and Q3, they are very important part of any data or variable. Q1 is the first quartile. Quartiles are what? Quartiles, there are three quartiles, Q1, Q2, and Q3, that actually separates the data in 4 equal parts. Q1 is the value in the data point, which means 25% of the data are below that and 75% are above that. Median is the middlemost observation, which is same as calling it Q2, and Q3 is the third quartile, which actually tells that 75% of the data are below that and 25% are above that. They actually give us the nice distribution for the data which we really want. If there is something in the data set, they will capture. And why they are in particular very important, there is a way of calculating the outlier in a data set by using these measures. What we do there, we actually calculate the interquartile range, IQR, that is given here as 11.50 for the variable height. How that is coming? That is coming as subtracting Q1 from Q3. And what we do after that, we make a little bit of math on the IQR to find out whether there is an outlier in the data set. It could be on the lower end or it could be on the upper end. And outliers are very bad for any statistical analysis because they are data, they are numbers, they can make and break the whole analysis. So we really have to be careful about identifying them. As a data scientist, we always find out the outliers. We don't make a decision about what to do with them. We make the decision if we are talking to the experimenter or if we are the experimenter, if we want to keep that data in the data set or not. For example, I mean, this is a simple example that I give as an outlier in the, when I lecture in the class. Say we are going to a shopping mall to buy something. Now there are always, we are like a group of people who just go and buy something. But there are always very rich people. They want to splurge money in the shopping mall. They want to buy a lot of things. Do you think they are not important? They are very important for those retailers. So what the consumer or the retailers, they do, they look at all the customers. They find out who is buying what or what kind of customers are buying what. So they have a cluster of customers who are really splurging a lot of money. Probably if you just add their money up, they are buying more than like the remaining 90% of the customers. So they are outliers in the sense of the data, but they are very important customers for the retailers. So they need to identify that, and they really don't need to take those off. They want to keep them because they want to know what they want, because that's their base. Even outliers are very important to understand in another context if you think about. So we all know that there are a lot of clinical trials are going on for the COVID vaccine. for any vaccine or any drug that is introduced in the market, there are different phases of clinical trials that go on, and they all depends on the data, and the statistical analysis are needed for that. For example, suppose there is a cancer drug that to be introduced in the market, and the drug company has experimented over the years on the patients for using that drug. Suppose using that drug, a person can survive 2 more years, or a person can survive 5 more years, or a person can survive 4 more years. So they get the data from say 20 persons like that. It's not very easy data to get. That's what I'm saying, 20% data. Now all of a sudden they saw that there are person who actually is really performing well, and that person is surviving say 15 years using that drug. Do you think that data should be included to introduce the drug? Drug company will be happy to put that data so that their number of years of survival look good, but that is an outlier. If on an average the persons are surviving 2 to 5 years, that's the real data. That should be counted when you are actually making inference about that drug. You should not include the person who is surviving 15 years using the drug. That person probably an outlier, and he or she is lucky, and he or she is actually kind of responding to the drug very well and surviving that many years. But that is a real outlier to be identified and should be checked so that we make a decision whether to keep it in the model or whether to keep it in the analysis or not. So that's the reason every variable has to be checked before even you do any kind of analysis. And that's the reason we have all the variables here to go for those kind of analysis. Now let's go back to our lecture. What we have next? Okay, we have the categorical data. Let's actually finish that part and then come back. So for the categorical data, what we have seen, diet is one and gender is one. How do I manipulate or play with that data? They are very simple. At the same time, we really need to know what's going on with that data. So I'm going to go to visualize the categorical variable, suppose gender. As I said before, when I'm getting the data from somebody, there should be an even distribution of gender, or at least close distribution of gender, so that when I'm making the inference about this particular problem, that should make sense. Say we take gender as our categorical variable. Now for this, what we can do, we can go to the graph, and very simple way we can make a simple bar chart. Again, simple bar chart. Let's see what we get out of this. So I put gender here and what we get. Very simple bar chart, and what we see here, we have the chart coming as like this. As we just defined, I believe 0 was female and 1 was male. So probably they are counted evenly. I can see the females are counted more, and probably females are, I mean, it makes sense. Probably females are more prone to think about their diet and whatnot. So they want to be in this program more. So that kind of makes sense, but they are not really drastically different. What I can see from the graph. Well, anything that we see from the graph is visualization. It's not inference. It is from the data. Let's see about the diet. What we have in the diet. So if I just graph the diet, well, again, not bad. So they are kind of evenly given to the participants who are in the diet plan. 1 is a little bit lower than 2 and 3, but I will not say they're bad. So it's kind of the study or the experiment was designed, I will say, quite okay. So this is what we see from the diet. If we want to see it in a different way, I can graph it very well with a pie chart. That is another very simple way of looking at the categorical variable. So let's see the gender. I just click OK, and what we can see is the simplest way of categorical variable. 0 is represented in blue and 1 is represented in maroon. So these are the first few steps, but the first few very important steps to understand the data. Now, once we have a very good idea about the data, we can start thinking about what questions we have about the data or what is our hypothesis about the data. And of course, when you do the experiment in the lab, you have a question in mind that you start with, and from there you go to the next step, how I'm going to collect the data, how I'm going to use that variable, or what exactly is that variable, how many data points we need. Every question has a very analytic answer from the statistical viewpoint. And we do each and every question when we are doing any research project, every question is answered very thoroughly so that you can see what's going on with the whole process. Now I'm going back to my lecture again. So what is the next we can see after we see the data variable? I'm going to give a pause here just to see if there is any question, 1 or 2 quick questions. Because I need to get some water. Go ahead. Any question, 1 or 2 quick questions? Yeah, 1 or 2 questions quickly. Or anything from the panelist as well. Okay. Okay, good. So what we have here, I have plotted the 2 male and female, then the diet in the same graph, just to see what's going on with each of these categorical data. You can do the box plot for categorical data or for the continuous data as well. So these are, again, all of these are going to show me how the data is. And frankly speaking, for the data scientist or data analyst or statistician, processing, pre-processing, and kind of making the data in a good format is probably the 60 to 70% of our job. If we know the hypothesis, these days every software is there to use that to get the formatted data and run the software. We get the analysis done probably in few seconds, technically few seconds, if you know what technique should be used. The hard part is to arrange the data and to clean the data. These are all good data set that I am showing you. In reality, we don't get this kind of good data set. We really need to go back and forth to get our data clean, to get the enough data, to get the right variables, to get the right measurements. Everything takes a whole lot of time. And that's what my collaborators at Clarkson, they say, our job is really easy. Well, it's not easy because they do experiments over the years and we do the analysis in few days. So, I mean, that's the good part of being a statistician, but that's not the right way of saying that because we already understood the technique, theory, and everything so that we can use them very meaningfully. Now, I have shown you, you can see all these slides later. I have given you how to use the softwares and the results that I have. I kept all the variables at the same time so that I can see what's going on, and the output summary and all are given in this summary statistics. Then I just show you a very meaningful way of looking at the data that is grouped. So far, what we have seen is the calculation of the mean, median, mode, and all, having with just the numbers itself, and most of the time we get it this way, but sometimes we get a grouped data where the individual's identity is not there. For example, here I have the 50 people who are showing their weight in a grouped way. So the frequency, if you see 6 for the weight, 40 to 49 kgs, there are 6 of them. I don't know who is having what weight, but I can see the representative weight in that group. Whereas there are 8 persons who belongs to the weight group of 50 to 59, whatever the unit may be. But if somebody asks me, can you give me a representative mean for this? Yes, of course we can. And what we do, again, these are kind of approximation we do. We get the value that is the middle mark of the weight group for each of the group, and we take that as our value of the variable. What is my variable here? My variable is the weight, okay, which is a continuous random variable, and then we take that as the variable which I have shown in the letter. Like we have the frequency for each group as 6, 18, 12, 14, 7 and 3, which corresponding to 50 people, and we have taken the representative weight for the group of 40 to 49 as 44.5. Then the theory says we make a multiplication of the corresponding frequency with their class mark of the particular group and get that data as our new data set. Then we sum all the multiplied values and take the mean of that value as a representative mean for this particular data set. There are questions on this kind of analysis. Again, if your group is different, suppose I am making the group as a weight 40 to 49, I will get a mean value for that group, which is different than if somebody is taking the group as 41 to 50. So the results will be very close to each other, but they are not going to be unique. That's one thing, but they are going to be very close to each other, which is what the meaning that we are trying to carry from this analysis. And we got the mean for this particular data set as 67.9. Somebody may get a little bit different numbers if the grouping is different, but at the same time, they will be very close to each other, which carries the meaning. These are all sample data. You are trying to understand what's going on with the data. It's not that you are going to get the same answer for each. If I give this same problem to everybody, they should all get the same number, 67.9 as the weight. But if I give you the data, or if I ask you to arrange the data with a class of 40 to 49, then you will see that there are different answers coming on, but they should be very close to each other. And that's the beauty of samples. 200 of you are sitting here, and if I ask you, go and get 50 people's weight, you all will bring me somewhere or other different numbers of the weights of the 50 people over that range of the age group. But if I take the mean of that age group, I'm going to see very close numbers. That's the beauty of the data. The data tells us what is going on if they are collected with the same strategy. Next, what I have, the median. Again, if it is the formula, and I have seen Papia has explained quite a bit, and there are other classes where you have seen the grouped data where the median is calculated. Very simple formula. If you look at here, you just need the class boundary, you need the size, you need the frequency, total frequency, and cumulative frequency, which is very easy to get even if you have millions of data. They are calculated from using the software just in 1 second. And I have plugged in all the values here, and I got the median for this data set as 68.67, which is very close to the mean. So that tells me the data is pretty good data because they are consistently giving me the same numbers. Same way, I can calculate the mode. Now, mode is basically the most fashionable value that we see in the data, or to simplistic way, when we say it is the value which is occurring the most of the times. And here is the way to calculate when we have a grouped data. And all this frequency of the modal class, every number is given and in the data, and I plugged in the numbers to get the number as 71.72, which is close, but not as close as the mean and median were, but still it is the representative number of the data set. Once we are done with that, we are going to now check a little bit about the bivariate data. Well, I'm talking about bivariate because bivariate is not the only word that I should use. I should use the word multivariate. Bivariate is just a part of it. So far, what we have seen with the data, each variable one at a time, and we have looked into finding the mean, median, mode, and whatnot. But our analysis, our intention, our hypothesis does not depend on looking at one variable at a time. Very simple understanding of that. We want to go for understanding two variables, how they are behaving, three variables, how they are behaving at a time. Univariate is just a part of the multivariate. Well, if we know the multivariate, that is multivariable data set, which is the case in 99% of the time. And we can just plug in, like in the multivariate data set, k equals to 1 to get the univariate, or k equals to 2 for the bivariate. So we go with the next step of learning, that is our correlation understanding, correlation coefficients. Again, it is one of the most useful understanding of the variables which are related to each other or not related if we want to find out. So we start with very simple correlation or correlation coefficients, which gives us the meaning what is the statistical relationship between just two variables. So what this correlation, it's a number which does not have any unit. If you look at the formula, I'll show you in the next slide, or probably the next slide. If you look at the formula, the numerator and denominator of the formula has the same variable. That's why the units get cancelled in the numerator and denominator. And it's very easy to see or to get that number to make a comparison. We always say this kind of examples in the class. For example, I have an undergraduate class in biology major that I'm teaching at USA, and Papia is teaching at Vijay Krishna College. I want to see what is the height distribution of the height and weight distribution of the, say, female students in our classes, for example. So I have, say, 50 students in my class. I get their height and weight distribution, okay? I get the height in inches, I get the weight in pounds, whereas Papia gets the height in, say, centimeters and the weight in kgs. So we have two different group of subjects, one from the USA, one from the India, and we want to measure. They are the same age group of students with the same understanding, with the same background, okay? So what is different? We got the data in two different units. How do I make the calculation? First of all, we can change the unit easily. We can do that. Even not, Papia calculated her correlation coefficient. I did. They can be easily comparable. Why? Because the correlation coefficient at the end of the day is a unitless measure. I find that there is a strong positive correlation between the height and weight of the USA female students. Papia finds that there is a maybe moderately strong correlation between the height and weight of the female students in her college. So we can get those kind of numbers and compare with just a simple correlation very easily. How to interpret? These are some kind of rules that we follow. They are not like the strictest way that we can call a rule. We have the absolute value of R. If that is 0 or close to 0, we can say there is no linear relationship between the two variables under consideration. If the value is between negative 0.2 to positive 0.2, we can call that as very weak correlation. Whereas if the value is between like negative 0.2 to negative 0.4 to negative 0.2 or 0.2 to positive 0.4, we can call it weak correlation. And similarly, we can go up to this way. Anything between 0.6 to 0.8 plus or minus, we call kind of strong correlation, either positive or negative. And if it is more than 0.8 or less than negative 0.8, we start calling it a very strong correlation, positive or negative. We have several examples that to see how the two variables are correlated. Height weight is just the basic example that we start with. We also give examples like this. Say we have a lot of engineering students at Clarkson who takes the statistics course, but they all have to take mathematics course at the same time. So I have in mind, this is my hypothesis, well, the students who are good in math, before they start even the stat course of mine, the engineering stat course, I have a notion, well, they are coming from engineering backgrounds. So I'm expecting their stat scores or the stat skills will be good because they have to take some prerequisite math courses to qualify to take the stat course. And I have seen that there is a strong positive correlation if they are good in math, they automatically do good in the statistics. That I have seen. Whereas there are other cases, we can see that probably there are students, like at Clarkson, everybody has to take a stat course or a course which has significant stat component. So even the history major or political science major, they have to take some kind of statistical knowledge. So if you see the scores, probably they are very good in history, but probably not performing as good as in the statistics course. But there are always students who do really good. And of course, there are students who do really bad in both. So there are cases like that. So we can find with this easy method very easily how these things are performing. Question is how you do that? Just to get the idea how the plots will look, you will find these plots everywhere. When there are data, like the maximum positive correlation means it's basically a straight line where all the dots are going in the line. We call it perfect positive correlation. And if you look at the data, like the perfect maximum negative correlation, or we call perfect negative correlation, when the dots are in a negative way coming down, then we can see a positive trend or we can see a negative trend. These are very simple and well established graph you can see. Now I'm coming to the way or quantification that we can find out the correlation coefficient, because we can see the data by plotting them, but it's always needed to see how they actually behave, or without quantification we cannot really say anything about how the numbers are behaving. So we have what? We have Pearson's statistician who calculated this or who did research on this and gave us this formula, which is very easy to see how it is calculated. Basically, we have two variables to start with. One is we are calling X, maybe height. We are calling it Y, the weight, X and Y. Simple formula. What we do, we multiply the two variables. We take the sum of one variable. We take the square of each variable, then take the sum, and all these numbers are given here. As I can see, you can see the formula, you definitely can do it with the problem, but it's better to use the software, because if you have more data or if you are changing the data, it's like time consuming to do it by hand. We never kind of encourage students to do that. What are the things we should do before even we use the formula? We first need to check few assumptions. One is the two variables should be measured at the continuous level, because we are trying to find out the correlation coefficient using Pearson formula. There are formula which actually takes care of the categorical data when you understand, which is a non-parametric counterpart of the Pearson's formula called Spearman's rank correlation. Then if there is a linear trend that we can see by plotting them, then it is meaningful to use this formula and understand. Very, very, very important to hear that outliers should be removed. There are data that we really need to check for the normality assumption before we actually use any kind of technique. You'll see in the t-test that is coming later, we really need to check for the normal distribution assumption. But Pearson's formula actually does not bother about that assumption a lot. If it is normally distributed, it's very good. But if it does not, it's not that bad. Then we calculate the number using the formula, and we get to that point, the calculation that is coming up. So I will show you now with this data set. So I have actually two data set, and I'm going to show you using these two data set all the things that I'm trying to teach today, where I have 42 newborn babies with their physical birth conditions, that we don't know who is who, but we have the identifier for each and every baby. Their head circumference is there, then length, and then we have the continuous variables that is given as head circumference, length, birth weight, and mother's age, and we have the discrete variable that is the birth weight class. So we have categorized them in two, one is low and one is normal. So let's go and see what we can find from the data over here. So we have the software here. Okay. Please, one person just tell me if you can see this data set where I have ID, head circumference, length, birth weight. One person, please.
There is a data sheet, sample data for Pearson correlation coefficient only.
Okay, so let me
No
share.
more, no other screen.
Okay, hold on. So can you see my Minitab screen now? It says on the top,
Yes.
chi-square goodness of fit, and then the data set.
Yes.
Okay. Okay. So this is my new data set, what I'm going to use to understand the concept that we just have seen. We want to check for the correlation, and let's see if the birth weight, you can see in C4, and the length for this particular group of kids, if we can make some kind of correlation out of it. And if I just look at these numbers, there are other things. Well, for the data set, I'm just going to tell you the head circumference, length, birth weight, gestation period. These are all continuous variable. Probably the smoker, this variable is for the mother, whether the mother was a smoker or not, that was counted. And then the mother's age is counted. And if the birth weight of the kid is low or normal, that is counted. So there are different values, different variables, they are under consideration, and probably the experimenter wants to study different things out of it. We just want to first see if there is a relation between the length and the weight of the kids. As I said, first it is the correlation that we want to see. If I just click the graph, the first option that comes here is the scatter plot. Scatter plot is the first step that we take when we start learning correlation. Correlation or regression starts with looking at the variable. The first thing is the scatter plot. Scatter plot between any two variables. We want to see how they are behaving. So I click that scatter plot. Again, you can see so many different ways you can do it. I'm just going with the simple one. Click OK, and I will have the variables that is coming here as y variable or x variable. Here is one thing, very important. When you are making the scatter plot for the correlation, it really does not matter which one you are talking as y, which one you are talking as x, because the correlation coefficient is not going to change based on the definition of the y or the x. It is very much important when you are doing the regression to make sure to call the y variable as y, which is the dependent variable, and the x variable, that is the independent variable, as x. But in correlation, the number r, correlation coefficient, or the Pearson's correlation coefficient, is not depending on which one you are calling x or y. But always it's meaningful to call the y, the x. Here we have seen the length and weight of the kids, the really newborn kids. So I'm just going to bring it here, say the length, double click here, and then the x variable, I'm going to click the birth weight. You can have many scatter plot at the same time, bringing anything you want, any combination you want, but I just need it this. I'm just going to click OK here. Let's see what we get. Okay, so this is what we get. I will not say that this is a very good data set to plot this way, because they're kind of showing like as a discrete type, but I can still see a pattern here. And the pattern will be more captured if we can find the correlation coefficient. How you do that? Okay, first of all, I go to stat, and then I go to basic statistics. Then there are options. If you can see here, I'm going to go to the correlation, and here I want the correlation between the length and the birth weight. As I said, I just need these two. Really doesn't matter which one I'm calling first, which one I'm calling second. I'm just going to click OK, and the number that I get, that is given using this software as R.671. Now, based on our numbers that we just got, we have the correlation we called 0.671, kind of, it's positive correlation, kind of strong positive, which is making sense. And we can see a confidence interval coming here, which I'm going to go later, what exactly we do with all these things, because R, mean, median, mode, all these numbers that we get are based on the data. We can talk about this, but that is just solely based on the data. We have to make inference if we know the inferential statistics, which is actually making the hypothesis test and finding the confidence intervals for. And that is integral part of statistics. Without that, we cannot say anything convincingly about the data. And that's what a big learning of our statistical literature. So what we just did, we find the correlation coefficient, and you see it's very simple to calculate. Again, this is just a few data points. If you have many data points, using the software is the way to go. Now, if we want to go for the same data set, suppose I want to find the other part of the correlation coefficient, which is a Spearman's rank correlation, which is mostly based on the data which are non-parametric or at the same time not like distributed normally. It's just a one click away using the software. I had given the formula. I'll come back to that in the slide, but let me show you how to do with the software. Same stat, basic statistics. Then we go to correlation, same button. Okay. Now I go to option. The option that you can see, okay, I got a Spearman's before. Okay. I think I showed you the one that I wanted to show, but here are the two options here. Pearson is the first one, which is mostly the default case, and the Spearman's is the other case. So which one you want to do for the data, you just take that button. Confidence level, I believe you have some idea about the confidence level or the level of significance. 95% is the widely accepted confidence level. But if you want to be very restrictive about your inference, you can change it to 99. Or if you don't want to be too restrictive, you can change it to 90. Technically, it can be any number because it's a probability. It goes from 0 to 1 or 0 to 100%. So if I want to have a confidence level of 95, I'm just going to keep it like 95. And the Pearson correlation, I think we already have the number 0.697. And if I just click one more time for the Spearman, so I go to stat, then go to basic statistics, correlation, and I go to my option where I click the Spearman's, same 95%. I think they are pretty close to each other. So I get 0.671. So 0.697 is for the Pearson's correlation coefficient, which is the parametric part of calculating the correlation coefficient. And the non-parametric part, it's giving me a little bit more. So where is that? I think, yeah, 671 and 697. So these are the two ways of calculating the correlation coefficient, and what it tells us whether both the techniques, parametric or non-parametric, is telling me there is a strong positive correlation between the length and the birth weight of the data of the newborn kids. This is an integral part of learning the data. Now, I have several projects where we have different variables to understand. For example, suppose I want to study the COVID-19 patients if they are going to be infected or not based on their comorbid conditions. For example, I have, say, data for 200 patients, and I know that they got infected. Somehow I managed to get the data from some hospital where we can find that person has a BMI, the person has the data from hypertension, the person has the data of their weight, their height, even their ethnicity. So far, we have different data set. I can make a simple, nice correlation tables to find out whether their BMI is correlated with their hypertension. Most of the time, yes. So I can make a decision if that person has a high BMI, high hypertension, that person will have a high chance to be infected. And if I can show that with the correlations and later with a regression analysis that they have a strong relationship, which I can model it and tell, well, if this person has this much BMI, this much hypertension, this much weight, this much this, then that person could be getting infected. And I can use that model to myself later Probably if I know the model, I can put my BMI, I can put my hypertension number, I can put all other parameters that I know, which are independent variables, and I can see what are my chances to be getting infected based on other assumptions as well, that I'm in a place where the infection is going high, I'm not socially distancing myself, I'm not following all the rules, or whatnot was kind of impacted to make that model. So these techniques are extremely helpful and at the same time very strong, very basic, but very strong to understand about the data and to go to the later part to make any inference about the data. So we start with the basics, then we go gradually and sequentially to the next steps to understand about the data. So now if I go back to my lecture, so let's go to the next part of it. So here is basically the sample data for the Pearson correlation coefficient, what we talked about. Then we go one by one, what are the output that we see. These are all the steps that I already showed you with different software. This is the steps that we can follow to calculate the rank correlation, which is by Spearman's, where we just calculate the distance between the two different paired ranks and carry on from there. What is paired ranks means? I have the data for length, I have the data for weight. So before even I do use the Spearman's rank correlation, I have to rank the data. And that's the part of the non-parametric statistical literature they do. First, they rank the data. By that, what it means, they actually lose the actual data points. The rank is now the random variable or the variable of interest, and they use that ranks to calculate all these numbers. Advantage of it, like suppose I have a birth weight of 20 and I have a birth weight of an outlying kid, say 50, the rank will be suppose 4 and 5. So the 20 and 50 actually lose their identity. They became the rank as 4 and 5. And now I use those ranks. So if you have a lot of data which have lot of outlying observations, but at the same time, they are very important for your analysis, and the data does not follow any parametric distribution, Spearman's rank correlation is the way to go to understand what's going on with that data set. And this is the formula. So we calculate the ranks for each variable, and we take the D as the difference between the paired rank, and that becomes my new variable to be used. The formula becomes very simple once you calculate the D. It's RS, the rank correlation coefficient, 1 minus 6 sum of D square divided by N multiplied by N square minus 1, where N is the sample size, how many kids were there. D becomes the rank of the paired distance or the paired ranks, you take the difference, that's your new random variable, and we go on from there. Now, the next thing is the calculation. I have shown it here. You will be getting the data. You can check by yourself. This is the snapshot of the data, but I would prefer you to use the software if you can, then the learning will be complete and you will feel very confident about how to use this kind of software. They are very simple as I'm showing you. The videos are captured. So if you forget also, you can go back and check that part. And that's the way we teach in the class. So what we have after this, the rank correlation, is the good test of fit test. I think it is one of the most important technique that we follow in the categorical data analysis. And I would like you to now interact a little bit with me so that I know that you are following. I mean, I do that all the time in my class. Otherwise, the lecture is very, very boring. Why we need categorical data analysis? Any one person, jump in. Or Papia, you can pick a person who can give some understanding. Why we need that? Anyone?
What do you want to know? I just can't follow it.
I asked like why we need categorical data analysis. Can you give me an example to tell that, well, this is a situation, I need to look into the data. Like you have a question to get answered where the categorical data is important. Give me a practical example. Anybody?
Okay. From the student, or should I give it to you?
You can also.
Okay.
Anybody.
Suppose for biological sample, suppose you have done an experiment considering Mendelian hypothesis.
Very good.
From that you expect that two phenotype will come in a ratio 3:1.
Very good.
But when you have done the experiment, you was that it is coming approximately 2.5 and 1.5 or something like that. So that is your observed data, and your expected data you have to calculate from your total.
Right.
I mean, total numbers of individual that you have got, out of them 3% represent suppose a phenotype A, and 1% should represent a phenotype B. That means the ratio should be 3:1. But in biological sample, you will obviously get the values which are not mathematically similar and will not follow a ratio 3:1, but it will vary. So your observed data and your expected data will show a mild deviation.
Very
now,
good. Yeah.
of fit test, we actually analyze whether that is statistically significant or insignificant.
Very good. Excellent. Excellent.
And that they can understand. From the biological observation, they can understand.
Very good. Excellent. Okay. So I'm giving you another practical example. Like, this is very important for our engineering students most of the time. So they are in a power plant. What they see in the power plant, they see that the plant is open from Monday to Friday. Okay. And on the floor, they have to work. So there are a lot of workers. They are working on the floor on each day. The manager observes that Monday and Friday, there are more number of accidents happening on the floor. So they count the number of accidents. Suppose there are 10,000 workers work on the floor on that plant, and all of a sudden he or she started to observe the number of accidents, minor, major, whatever. They are counting the numbers. They are in numbers in Monday and Friday. And then there are a number of accidents on Tuesday, Wednesday, Thursday. So he or she started thinking, is it a real phenomenon? Probably he observed for like 5 or 6 weeks, and he is getting the data. If there are, say, 70 accidents on Monday, 67 accidents on Friday, there are like probably 25 or 30 accidents on Tuesday, Wednesday, or Thursday. What's going on? What is that? So what I'm going to expect, if there are even number of the 10,000 workers, more or less, that is the number of the workers every day in that floor, they are doing the same kind of work every day, what they're supposed to do. There should be the same number of accidents happening each day or close, like the proportion should be same. I should expect that the number of accidents or the proportion of accidents should be 1/5, right? And I have the numbers of the accidents. So it becomes kind of a categorical data because I have Monday, Tuesday, Wednesday, Thursday, Friday. And I can see that how I'm going to find out whether there is a discrepancy in the data or not. This is the test to check for that. Again, for example, suppose you want to go and buy flowers, say rose for your friend. Okay. So you went and checked in, say, 5 florists, and you went there and you saw that if you want to find rose, probably there are 4 types of rose are available: red, then say yellow, white, and say pink. And all of a sudden you started observing, probably you want to find for your friend yellow, the yellow is not available, red is available. You went to a next florist, you went and you see the same phenomenon. So technically speaking, if the flowers are grown randomly, the roses, there should be even distribution of the colors, unless and until, of course, that is the case, unless and until one color is given preference. So I'm going to expect that there should be same amount of colored roses as same amount of yellow roses. If they are growing in the wild, I will see that is the case. But there is something going on that kind of brings in your mind, well, no, roses are more reds because probably they are grown more. Why? There is a very simple answer for that. The demand is more for that. So we can find out using this simple technique what is the discrepancy between the data, and then from there we can find out what is the reason for that. First, statistically we have to prove that why the discrepancy. Why we have to prove that? Because data is data. They are randomly collected. what Papia said, what I said about the accidents, they could be just random events. Okay, probably the manager is thinking too much. I mean, if he looks into another month of data, probably he started seeing that Wednesday and Thursdays there are more accidents going on. Then there is no point. But if it is consistently going, there is something then in our mind, well, there is something that we need to change in the experiment, or there is something that is in that particular species that is happening to make it happen. So we need to think about it by finding or quantifying them. Goodness of fit test is one of the best well-used tests in this respect. This is actually the starting point. Most of the books actually stop after doing that, but I ask my students to go for the next step, which is doing some other tests to find out which group is actually behaving the different way, so that we can make sense out of it. What we did here, we have the observed value or the observed frequency, whatever you call. Then what is the expected value? Because the expected value will take us to the clue what we can find out from the goodness of fit test. So what we have here, the setup, then I'll show you with the data. So steps for goodness of fit test, we have the null hypothesis. Well, I'm expecting that you know what it means by null and alternative hypothesis. I'll give a brief introduction for that. Then we have a null hypothesis, that there is no significant difference between the observed and the expected value. Then we calculate the test statistic, which is the chi-square value. We call it test statistic, which is the variable or the random variable under this test. Then we compute that value with a table value, the tabulated value that is already done by the statistician or the researcher to make the comparison. And we make the decision based on whether our test statistic value is in the acceptance region or in the rejection region in our test process. And we make the conclusion. Now to do that, what I have again a simple data set. Let's go back to our data set. Again, I am back to that Minitab file where you have the flowered tulip and their colors. So what I have 3 different colors. I don't know which one is what. I don't care. Okay. I can see from the data that there are 3 different colors of tulip flowers, where one has a number 81, one has a number 50, one has a number 27. You can totally relate to your rose. Okay, you can think about 81 is the red rose, 50 probably the yellow, 27 probably the white or whatnot. What I'm expecting that if they are grown widely in the same atmosphere, it should be of different colors. So that means 1/3 should be coming from the first color, 1/3 from the second color, 1/3 from the third color. So this is what my data is. I want to use a simple test to find out what we can find out of this goodness of fit. To do that, again, I go back to my stat, where there is different ways you can do it in the software. I go to tables, so stat, tables, then I just go to tally individual variables. Very simple. And there are a lot of different chi-square tests actually available. I think I will go the other way. Let's see, tables. Yep. Okay, so probably I have, let's see if I can use this way. I have the two.
Shumana, just interrupting once.
Yeah.
2 or 3 very relevant questions regarding confidence limit is there. Will you just address them now or later?
I think it will be better if I address them. Okay, let's do that, because I think that is very important.
Because they have some confusion, I think, which must be clear first.
Excellent. Okay, actually I like that way, because this is what I'm showing, the data analysis. Inference is actually the part of it.
Yeah, for inference, you must know.
Okay.
The important question.
Can I just start writing a little bit? That will be easy. Okay, let me do it.
Some Kaushal want to know, ma'am, whether all the statistics are affected by the outliers at the same level.
Well, depends on what kind of outliers. It all depends on what test you are doing, what kind of data you have. No, the answer is no. Not all the statistics are affected equally by all kinds of outliers. First of all, what we need to know about the outliers. There are mild outliers, there are extreme outliers. As I said, sometimes the outliers are important to be kept in the data for the analysis. Sometimes they have to be deleted. So it depends totally on the outliers. Even if you have a lot of outliers in a data set, you have 10,000 data set, there are 1,000 data points which are kind of not going with the other data set. So that's a cluster of data point that is actually not an outlier. It looks like they're outlier. So you have to do some kind of data mining technique, for example, say clustering, to bring out that that is a cluster of data points who are behaving very differently. You have to break or make them separate before you do the analysis and then go from there. It actually depends on what you are trying to do based on your hypothesis.
Okay, then Sumona Mondal is asking, ma'am, why quartile 4 is not counted actually?
There is no quartile 4, okay? Because we want to separate the data set in 4 equal parts. If we want to separate the data set in 4 equal parts, we just need 3 separators. The 3 separators are enough to separate in 4 equal parts. That's why there are Q1, Q2, and Q3, 3 quartiles. Q1 is separating 25%, 75%, Q2 50%, and Q3 75% and 25%. Same way, there are 99 percentiles. You want to separate the whole data set into 100 equal parts. You just need 99 separators, and that's what is called P1, P2 up to P99, the percentiles that we calculate. If you want to call the decile, that is the separation of the data set into 10 equal parts, you need 9 separators. You don't need four quartiles. There are 4 parts of the data, but they are separated by 3 quartiles.
Ma'am, can you please define the confidence level against software?
Okay, I will do it right now. Okay, let's do it.
Actually, they have a problem regarding this 5% level of confidence.
Okay, awesome.
Not clear to them. So,
okay,
you please clear them why it is being considered as 0.05 alpha, especially, or why are you considering as 0.09, and exactly what it means? I mean, out of that concept.
Let's do that. I did not put it in my slide because I just did with the concept that Papia asked me to do, but this is the most important part of the learning. Okay, so let me start sharing. Let's see what we have. One second, let me check.
Not shared.
Not shared. No, I'm just trying to share the screen where I can write. Okay.
Okay.
So that I can show what I'm trying to.
Then probably you have to go to that whiteboard option.
Yes, that's what I'm trying.
An option, probably.
Yeah. Okay, why I cannot see in the whiteboard option here? Generally in my Zoom.
Sometimes it happens that somewhere you have to click probably. ওই whiteboard optionটা আসে না ওইটা সময় দেখা যায় না জুমে বড় স্ক্রিনে।
Hold on, let me try on a different way.
Concept of confidence limit is not clear to them.
I see.
In the last lectures, mine was on mean, median, mode, so I didn't deal with it.
Yep.
না না ওইটা ওই হোয়াইট বোর্ড অপশনটা খুলছে। After share screen, whiteboard is not coming?
Nope. Generally it comes. That's
It
what
comes,
I'm.
beside all the screens which are actually open or minimized, a whiteboard option also comes in the box.
Right. I checked it yesterday. I'm not sure what is the.
Let me see if I go for share screen. Then video clip, no, it's not coming. Advanced.
Yeah, generally it comes.
It may be so that in our license version, probably it is not given. It may
Okay.
be something like that.
Okay, okay.
Because
Yeah,
this-
I have that in my.
You may have, but since our license version may not support it or something,
Yeah.
it may happen. থাকবে না, থাকা তো উচিত।
থাকা উচিত, exactly.
থাকা উচিত। আমি কিন্তু এখানেও খুলছি, আমি দেখতে পাচ্ছি না, আমার ডেস্কটপটাতে ওবিএস চলছে বলে আমি পারছি না। এখানে কিন্তু শুধুমাত্র whatever screen are minimized in the laptop, they are coming. But in the free version also there is an option of whiteboard. In the free version also. Then why not coming? Okay, I think it's better that you
No,
make.
hold on.
Okay.
Use PowerPoint.
PowerPoint. Hold on. I think Shantanu is here to help me. Give me 1 second, okay?
No problem, no problem.
Yeah.
Yes. Yeah, now you can do.
Okay. Thank you. Shantanu is here to help me.
Shantanu.
No problem.
Thanks.
Our technical assistant as always. Okay. So everybody can see my screen now, right?
Yeah. Absolutely.
Okay.
Absolutely.
So I'm doing a very brief introduction of statistical inference. I think that will help us to understand what exactly it means by confidence level and not. So statistical inference is the main part, what we say, the data analysis, data meaning, whatnot, is actually statistical inference. Now, what I'm going to show, the inference for the population parameter, say mean. We can do it for anything, any parameter, because we always try to do the test for mean, for dependent test, independent test. That's what I'm just trying to do for mean. What we have learned, that the correlation coefficient, median, mode, each of them is a parameter, and we can do the statistical inference for all of them. It is broadly categorized in two ways. One we call theory of estimation, and the other one we call the testing of hypothesis. So when we say level of significance, confidence level, these are integral part of these two techniques equally. In estimation, we also can categorize it in two broad ways. One is very important, we do use it all the time, but for statistician, each and everything is important. One is called point estimation, and the other one is called interval estimation. Very simple. What is the difference between these two? For example, say I'm trying to guess your test score for the next biostat exam. As a teacher, I can make a statement in the class, well, I feel that your average test grade will be 67. I just make that statement. What I did some calculation based on the students' test results from previous years, and I make a point estimate. So that's a point estimation. If it is good, it is the best, but it is most of the time not a good way of putting the estimation numbers. What we do is we try to put in an interval estimation way, where I say, well, I am 95% confident that your average test score for the class is going to be between 65 and 72. So what I made an interval to predict your scores, and I believe that I'll be very good at saying that instead of saying a 67 as a point estimation. But again, both of them have different meanings and very important, I will say, interpretation depending on the situation. Interval estimation technically can be done in 3 ways depending on the situation. One we call confidence interval, which is the one that we all need to know, definitely very useful. Then there is something called prediction interval, and there is another way of doing the interval estimation called tolerance interval. So what we do emphasize in these basic statistical courses, how to know the confidence interval and what to do with the testing of hypothesis. Testing of hypothesis is building a hypothesis, which is an assertion about the parameter that is of our interest. So if I go to the, let me go to the, hold on, I think I have to go to next few slides. Just give me 1 second. So what we want to know from here, everybody can see? Is it shared, the screen?
No, it's your virtual background coming on the screen.
Okay, hold on. I have to just. Can you see this now? Okay. So what we just said, we want to see about the testing of hypothesis. So hypothesis testing again is based on the parameter that I want to make the test for. Again, I will go back to the same example. Suppose I'm teaching the class and I make a hypothesis. Well, this batch of this group of students are very good, and I'm very confident that as an experimenter, if I know that you are going to perform well, your average test score is going to be more than 67. And I am making this claim. So I am the experimenter because I'll be getting all the data from your scores. So there are 2 things that happens here. One is calling a hypothesis null hypothesis, one as the alternative hypothesis. This is the natural way of presenting them. There are different notation for that. Which one is what? That's very important. The alternative hypothesis is the one what the experimenter wants to show to be true. I'm trying to say that the average test grade is going to be 67 or more. So I'm going to write this as mu greater than 67. then naturally the other hypothesis, which is the negation of the other, will become mu less than equals 67. I deliberately put a equality sign here because I need that number 67 to make the process going. That's what you will see in every null hypothesis, there is an equality sign. Depending on the alternative hypothesis, the test process goes. This is called a one-sided test because I just put a greater than sign. It is called a one-sided test, which is also known as right-sided test or right-tail test. Similarly, I can have an alternative hypothesis, which is mu less than 67, which is again a one-sided test, but that is going to be a left-tail test. Based on the alternative hypothesis, the null hypothesis will be constructed. So what we need to know one, and natural process is that finding the alternative one, because naturally, whatever the experimenter tries to prove, that goes to the alternative. Now, as an experimenter or data scientist or data analyst, it's not that you want to prove your hypothesis. You want to set up your hypothesis. Data will tell you what is truth. You may get your hypothesis accepted or rejected based on the data. You are not going to force to prove your hypothesis. You are going to make a hypothesis. Data will tell the truth, what is going on. As I said, this is one set that can happen. It can happen that you have an alternative hypothesis that is less than 67, whereas a null hypothesis, just the negation of that, which is going to be greater than 67. At the same time, I can make a claim that my alternative hypothesis is mu not equals to 67. Same way, my null will be mu equals to 67. This is what is called the both-tailed test or two-sided test. Every software where whenever we do any process, this is the default test that we always do. This is the default process which will give us the two-sided confidence interval that we calculate about any data. What I say, the alternative hypothesis, if it is two-sided, it will be connected to the confidence interval that we get in reality. That means hypothesis test and confidence intervals are well connected. If I know the one, I know the other one. That's the way we learn the theory. Now the question is how the process goes. So if you go to the next, we will see that based on our alternative hypothesis and null hypothesis, we'll make the decision. But the decision is a big process. It's not that easy process to understand. And to get that part, we take some criteria or some way what we understand, what we need to know about the type 1 error and the type 2 error. What happens? So I'm going to give you this scenario. I think this is going to be very useful. So this is what I write as reality, and this is what we have the decisions based on that. What I'm trying to say, I'm going to give you another example for that to make the connection. In reality, you will see either your H0 is true or you will see your H0 is false. Everything is actually based on the H0 because H0, the null hypothesis, is very important. That is the prior belief. Okay, we don't want to accept or discard the prior belief just like that. We need a lot of data to have our alternative hypothesis going and to make a decision whether to reject or accept the null hypothesis. So it's very important that we know what is true, what is false. And what is that decision that we want to see? Either we reject the null hypothesis or we call it do not reject or fail to reject the null hypothesis. That's the way we call it. Basically, it is accepting the null hypothesis. So there are 4 situations you can see that can happen. One is when H0 is true and we reject the null hypothesis. That's a very bad situation. Okay, so I'm going to call it a wrong decision. When H0 is true and I'm still rejecting it. When H0 is false and I'm accepting it, that is another very wrong decision. At the same time, these are the 2 decisions which are actually correct decisions. How you can correlate this situation in reality? Think about a person is caught due to some kind of crime. So what we do in the criminal justice process, we want to go through some process to prove if the person has done anything wrong. Based on that proof, that person is given the decision whether to be punished or not punished. 4 situations can arise in this scenario. 2 are good, 2 are bad. One is that the person, it is proof that the person has done something wrong and the person is given the punishment. Very good decision. The person has done nothing wrong and the person is released. Very good decision. No compromise on that. These are the 2 decisions that we always want to achieve, but that does not happen in reality. There are 2 wrong decisions that can happen. One is the person has done something wrong and he or she did not get any punishment. That's a very wrong decision. But the worst decision is, that is in the criminal justice, that it happens, the person has not done anything wrong and the process finds him or her guilty. Nothing can beat this decision, and that is the worst decision that can happen. You can think the same way, this one as the worst decision that can happen. As I said, null hypothesis is the key part of any testing process. If it is true and you find some data that supports your hypothesis, which is the alternative hypothesis, and you force that data to make the decision that H0 is false, and you reject that, that is not true, that is not right. You have to have more data so that you convincingly say, well, this is an established theory, I'm getting repeatedly this data to prove that wrong, then it is acceptable. But with just one data set or one experiment, you find something and you say something that is totally wrong. So what I'm trying to say, this is the worst decision that can happen. And in statistical literature, this is what is known as type 1 error. So the type 1 error is what? It is the error when we are rejecting the null hypothesis when it is true. Similarly, this is what is known. This is what is known as the type 2 error. What happens in the statistical literature, we try to minimize these 2 errors simultaneously, which is theoretically very hard. So what we try to do, we want to keep this error as small as possible. Everything that I'm talking about, type 1, type 2 error, is a probability in the literature. So what happens, we try to minimize the probability of type 1 error. And we all know that probability can go from 0 to 1, 0 to 100% technically. So the type 1 error, we try to keep as small as possible. And that's what the terms come, the level of significance. So the level of significance that we use, the numbers, say 0.05, 0.01, 0.1, these are actually the probability of type 1 error. We want to be very confident about your test process. So we want to keep this error as low as possible. As low as possible, this is a very low number. We can even keep it 0.001. So that's the reason. This is the level of significance, which is the probability of making the type 1 error, which is rejecting the null hypothesis when it is true, as small as possible. To come to that achievement, we really need to have a very strong experiment. We really need to have a lot of data. We really need to have a good data set to make that happen. And then the test process runs and make the decision. That's the reason you will always see there is a level of significance that is going very small, and we like to keep it as small as possible. Level of significance actually is the number, and confidence interval or confidence level we call like 95%. So they are all related. Level of significance is the probability of type 1 error, which is the complement of the confidence level that we call 95%, 99%, whatnot. So when you say that I'm 95% confident that this is what my data belongs to, that means if I do a testing process on that data to make that my hypothesis clean, I have taken the level of significance as 0.05. So 95% confidence interval corresponds to 5% level of significance. 99% confidence interval corresponds to 1% of level of significance. And that's the way we go to the next level of the structure. And as I said, all these kind of scenario, they have a solid theoretical background to prove what is wrong, what is not wrong.
Hello,
Does it
ma'am.
make sense? Yeah.
On what basis are we making the alternative hypothesis? Is it only by observations?
No, this is a lot of times by observation, but at the same time, like suppose Shuja is doing an experiment. He has a lot of experience in that field, right? So he has observation and he is seeing some phenomenon again and again and again. Based on that phenomenon, he has some question, and that he's trying to build through a mathematical process, which is your hypothesis, and that's the alternative hypothesis.
So, ma'am, you said that before starting an experiment, we are making H naught or HA. So how can we make it before making an experiment? After making the experiment, we can put the alternative hypothesis.
No, you have to have some question in your mind. Okay, experiment is the manifestation. You have, of course, you are doing the experiment. It's not that you are doing the experiment. You are reading the papers. The literature says something, and you are observing something. Without observation, no question comes. So you cannot just blindly start with a question. That comes with lot of observation and study.
Okay, ma'am. I have another question. The value of level of significance is 5% or 0.05. So why is it not 0.04 or 0.03?
It is anything. It is anything. Everything is. It's a probability. Technically, it can go from 1 to 100. Okay, it is any number. We like to keep it as small as possible. These are default values. So when I teach in the class as a statistician, for me 0.01, 0.1 or 0.02 does not matter. We learn how to read the table for every number. This is the strategy that is followed in the literature. Okay, that's why we take 0.01. It can be any number, 0.001, 0.0001, anything, technically from 0 to 1. It's a probability.
Thank you, ma'am. Thank you, ma'am.
Any other question? Okay, so if not, I think this is kind of the basic understanding of the hypothesis test. Now you have to be very careful about what is your alternative hypothesis. Based on one-sided or two-sided, you go and make the decision about it. So let me go back to the chi-square. That now you will understand what I have done there for the hypothesis testing.
Yes,
so I will stop sharing. Go back to
now
my
it
slide.
will be okay, fine for them.
Very good. Excellent.
Thank you.
So I'll go back this. So you can see the chi-square test, goodness of fit, right? So what we had the tulip example, right? From the data, we can see that there were probably like 81 from 80. I have the number here also. 81 from first group, 50 from the second group, 27 from the third group. Technically speaking, as I have in my mind as an experimenter, that there should be a fair distribution of the colors, but I can see there is discrepancy in the numbers. How do I prove that? This is the way to do with the chi-square test. So we did the chi-square test. We got a very low p-value. Okay, p-value, again, another part of the learning. So hypothesis test can be actually completed in two ways. One, we call it a classical way of looking at the data or the interpretation, and the p-value. P-value is getting very popular because this is one number that can tell us very well. P-value and classical way of finding the hypothesis test results are all giving the same answer. If there is something wrong, that means our process is wrong. The mathematics cannot give two answers with the two different methods, but we get the same answer. P-value is actually the observed type 1 error. What I mean, type 1 error, the alpha value, what we have said, say 0.05 or 0.01, we actually fix ourselves before we actually run the process. It is fixed. So we make the decision based on the actual value of alpha, which is called the p-value. So p-value is the observed alpha. What is the rule? That if my p-value is less than the alpha, which is my given probability of type 1 error at the beginning, I'm very confident that my data is saying whatever I'm trying to say as an alternative hypothesis. So we reject the null hypothesis only when we see the p-value that is less than alpha. Our alpha is itself small when we start. We keep our alpha as small as possible, 0.05, 0.01, 0.001. If I see the p-value is coming even lesser than that, then we are very confident about our data to make the decision. Most of the time, all of the time, if your p-value is less than alpha, then you reject the null hypothesis. As I'm saying repeatedly, null hypothesis is the prior belief. We don't reject this as easily. We have to have lot of support to make that decision. So in this case, in particular, we get the chi-square test statistic value 27.88, which is technically speaking as a number for a random variable very high. When the number for the random variable is very high, it mostly falls in the tail area of the distribution. So if you think about a normal distribution that is a Gaussian tail, if my value of the test statistic fall in the tail area, that means it's highly probable that something is wrong, because most of the data distribution is in the middle portion of the random variable. If the value is very high, that means I am getting the number that is supporting that the null hypothesis should be rejected. Same time, the high value of the test statistic will correspond to a very low value of the p. And that's what is happening in this tulip example. So you see the value of p is extremely low, like it's negative 0.000 something. That gives me the strength that I have a justification from this data to say that the colors are not evenly distributed in that tulip case. So there is something. I'm not saying which one is more, which one is less. I just said that there is not an even distribution of the colors in this case. So this is what the chi-square test of goodness fit does. Now, again, the last part of it is the parametric or the non-parametric, actually parametric t-test for equal variance and unequal variance. What we have here, very simple example, that I have the weight distribution of the males and females in my class. I want to find out whether the weights are equally distributed or not. My alternative hypothesis as an experimenter will be probably the boys have more weights. Or to do a fair justification, suppose I'm teaching a class with 200 students and there are like even distribution of male and female students. I'm teaching the same course to all the students. They're using the same material. They're learning the same thing. Their level is same. They're coming from the same background. I'll expect the average test scores for my course will be similar between the male and female. So I have their data. If the data are coming from male and female separately, two different population. So that is what is called the independent t-test that is following here. And I'm going to use the test to find the process where if the variance is same, I'm going to use this formula. When the variance is different, variance same and different also is a statistical proof. It's not that observation, okay? We have a test using F-test statistic and chi-square test statistic, and for more variance is the Bartlett's test statistic to prove that if the variances are same or not for the different categories. Suppose I prove that, or I know that the variances are the same, then I'm going to use one formula. If they are different, then I'm going to use this formula. Any software will ask you that option if you want to do the t-test for the independent sample and then make the decision what's going on with the data. So this is what that test process. I think I have the data and I have the result here with the steps. So you have again the same example, like same type of example, male and female diabetic patients. I have the data. I have their observation from 5 male and 5 female. I wanted to see if there is any difference between them. And what I see from this data set that the p-value is actually more than, okay, p-value we got 0.013, which is less than 0.05. So there is a difference between the data of the weights of those patients coming from male and female. So this is what is for the unpaired And for the paired, this is again very interesting and important. I know for a lot of biological research it is done. You are getting the data from the same subjects on different occasions. And that's what the dependent sample test comes to the picture. For example, same scenario if I want to give, I'm teaching the class where I'm giving them 3 tests over the semester. And I find that, well, the students are learning very fast. They are doing very good. Is there any improvement in the students' scores? I can randomly select the students, then suppose I take the students, they become my students, okay? So I don't count them as male or female. This is one scenario. Suppose I want to separately study if my male students or my female students are achieving the, I will say, achieving the improvement equally in the whole scenario. Then I'm going to take my male students' data from test 1. I'm going to take the same male students, take their second test scores and see that if there is a significant improvement. I will do the same thing for the female students, same group of students or the same subjects for the test 1 score and for the test 2 scores. And I will make the comparison to make what is going on. What is going on here for the dependent sample case? I'm taking the data from the same subjects. That makes sense. If I take, say, Papia is in my class, I'm taking her first test score, I'm taking her second test score. I can take a difference between her test score because it's her. But if I take a random sample for the test 1 scores and a random sample from test 2 scores, I cannot take the difference between the 2 test scenario because they're coming from different subjects. What I can take the difference is the difference of their averages because they're representing the class. So the dependent sample situation comes from the scenario where I'm taking the data from the same subjects over and over and over. If there are 2 cases or 2 scenarios, we use the dependent sample t-test. If there are more than 2, we use something called repeated randomized design of experiments, repeated measures, and that's what it is. And the independent sample, when we are taking the data from different subjects at the same time, the extension from 2 to many is the analysis of variance or the ANOVA technique that we conduct. And we get the results out of there and we make the conclusion. Same process, we calculate the test statistic, make the process. We have a null and alternative hypothesis that we develop, like there is an improvement. As an experimenter, I want to prove that there is an improvement. What I'm calling improvement, the average test scores in the second test is more than the average test scores of the first test. That's my improvement. That's what I define my improvement. And I can make the decision likewise. So I can go this way from one to another and make the decision. These are the results I have given. The way you can do this, I'm going to send the data. I think for the time, I'm going to skip the details, but you can definitely check that. Now, I think this is kind of a good homework. You have the answer here. You will have the data. The homework is that if you can run the data in the software and get the same number. So that's a good homework. You already have the answer to check that whether you understand what's the process is doing. And I think I would like to stop here today. Thank you for being the most patient students in the class. I generally have too many questions. I think Papia has told you not to ask questions in between. Otherwise, I generally encourage too many questions in the class. But right now, I'm going to take your questions if you have.
No, actually, since it is in webinar mode, they are automatically muted. So they can do their question answer and can raise the hand. Then I have to unmute. That's I have done for Shoumu. So now they can interact and they have put the questions in the both chat box as well as in question answer.
Okay, now I think I am ready to take questions.
Exactly. Somebody has written that, ma'am, Arif has written, ma'am, how do we rank the variables for calculating Spearman's correlation? Is there any hard and fast rule of ranking the variable?
Depends, okay? So you rank the data. Generally, we rank from the lowest to the highest. But there are always tie, like same numbers can appear twice. So we make them a tie. For example, say I am ranking the scores. I have 3 students who are scoring 70. Then how I'm going to rank them? suppose those 3 students in my ranked data set would have come in the 5th, 6th, and 7th position, right? So they should have given 5th, 6th, and 7th, but they are scoring the same number. So what I'm going to do, 5 plus 6 plus 7 divided by 3, whatever that number, I'm going to put the rank as say 666 for all of them. So there are different ways to rank them depending on the data. You will have data where there is no tie. So you will get the rank from say 1 to 20, whatever, if you have 20 data set.
Okay.
If you use software, you really don't need to worry about that. And I strongly encourage to use software because you are not going to deal with 20 data points. You will probably deal with 2000 data points.
This Minitab software is free. I mean, they can download it or
download for 30 days.
30.
Definitely. And the student version is very cheap. And I encourage like your university either to buy SPSS is exactly similar, absolutely similar, right? I could have showed in SPSS, but my license is expired. The school installed in our computer, so I could not show it, but they did for the Minitab. So we have to extend the license every year. Every university should be able to buy that for the students, and you don't need to have it in many computers. Just few computers could be dedicated. They can bring their data and do the analysis.
But what happens over here, our institution also has SPSS. Most of the institution have SPSS, but the students actually in Calcutta University, probably they can handle it. But in general colleges, undergraduate colleges, students are not allowed to handle it.
Why?
Problem. Because I don't know. But
I think there should be one person who can teach them, like in this course, like the biostat course. What we do in our course, we have the class lectures where we do show everything, but students are given an assignment every week where they have to use the software. So that is a dedicated computer lab with 25 computers. So depending on the number of students, they go there once a week. So they are given an assignment where they have to use the software to run those problems. They have to submit those assignments. And there is a kind of a lab instructor who teaches them how to use because when you are learning for the first time, you need to know what are the steps, how to get the data, how to export the file, everything.
Over here, what happens, students who have computer science or computer application as their honors, they can use the computer lab. But other students who have only a part as biostatistics, they still use that old method of using calculator and everything.
I don't encourage that. Yeah, I think it's time to
at least this in science department, at least one computer should be there, at least Minitab or SPSS, so that the student can handle it.
Absolutely. They need to learn it because if they're going for research and all, they need to use it. So it's better to learn at this level, and it's very useful.
They can do it at PG level, but not in the UG level still now.
It should be from you. Even it should be from the high school level.
Okay, there is a question from Shagota. What is the difference of use between Pearson correlation and Spearman correlation?
Okay, so Pearson correlation, you are using the data itself, and you did not, you actually prove that the data are good data in the sense they are coming from a normally distributed population. But a lot of times you get the data which is small in numbers, at the same time not following a particular distribution. Then the Spearman's rank correlation comes into the picture. It depends on the parametric or the non-parametric nature of the data. That's what I just showed you, like the t-test at the end, right? So independent t-test, that is a parametric situation where the data are coming from normally distributed population. If not, do we don't do the test? No, there are tests available. That is a non-parametric test called Mann-Whitney U-test. So there are non-parametric statistics is a big literature in the subject where they deal with the data which are not kind of, I will say, normal data. That's what it is.
Okay, somebody has raised your hand. I have unmuted you. You can question ma'am directly.
Yep.
What was the name? Just a minute. Rishika. Rishika, you can unmute yourself if you want for a direct question. Do you have any question? Otherwise, I will take the question from the question answer box. Oh, some Surojit has written, ma'am, your explanation on level of significance was so good that it made the understanding very lucid. Thank you, ma'am. Okay,
Well,
then Kaushal.
This is just a starting, okay? We have too many things to learn about that. I did not do any math today.
Yeah. Ma'am, why do we calculate goodness of fit test as square of chi-square? Why? Not as chi only.
Okay, very good question. Very good question. Think about this way. You want to measure the distance between the discrepancy, right? Now, if you take the distance as an absolute term, okay, there will be some of them positive, some of them negative. So you have a negative number, say -3, and a positive number 4. So if you add them up, actual distance, it will show as 1, which is not what you want. You want the real distance to be captured. So you squared them so that all the numbers become positive and you can actually calculate that. It is a Euclidean distance measure that we do when we actually calculate the distance to take the square to actually, it's easy to take the square and then take the square root and make the interpretation. But if you take the absolute numbers and take their sum, you will lose the understanding of the data because you are actually trying to find out the discrepancy between the data. Does it make sense?
Then Akashlina De is asking, ma'am, what characteristic will you like to see in a software to choose it for academic research and data interpretation?
Well, there are already so many well-established softwares that I know. I really don't need to choose anymore, okay? So I already have chosen mine. That is like 15 years back. So this is one of them, Minitab, SPSS, then there is Stata, then there are some free softwares, but these are getting very useful. And these are very good softwares for bio-related measures, but when we use actually real data, big data, we prefer to use MATLAB, R, Python to code your own technique so that you can run it again and again. Okay, here, still, if you have 20,000 data points, you run it, you get the results. Again, you bring another 1,000 data points, you have to run it again. But if you use that code, you really run the code. That's much easier. I mean, I know about SPSS because I studied in Calcutta University. Back in 2000, they had SPSS. I'm very confident it should be there.
That's why I'm telling, in the post-graduation, they will be able to handle SPSS, but in undergraduate colleges also, the principal or institutional head must be aware of it.
Absolutely, absolutely. Without that
department, which have actually statistics in their portion.
And I strongly recommend that because some of these students will probably go to other countries when they go for foreign, like I did the same, right? I came here, I was very kind of stumped to see how many softwares the kids from here they know. I mean, it's better to learn the same way because your understanding should be the same.
Okay, then another compliment from our student Oendrila Dash. Probably she is from Ashutosh College. Ma'am, being a non-stat student, it was initially difficult for me to get through these biostat webinars. But after today, it is not that tough. Thank you so much, ma'am, for making statistics interesting for me.
Okay, go for it. Be a statistician. If it is interesting to you, go for a statistics degree.
And okay, let me see whether any other, if you want to make question. Rishika, I am unmuting you. Can't you unmute yourself? I have already given you the permission, but probably.
Well, I can see one question from Devapriya Sanyal. Some more information on R programming. It's all free. Okay, I cannot give you one information. You just Google it. Everything is free. And why not Python? Why not Python? You can go for Python. Okay. my students, they use R mostly. That's what I put. I mean, we can use any software. Technically,
Actually,
any software.
for Python also in online, some tutorials are there which are free. My son is undergoing that tutorial and I am also watching that Python.
Exactly.
You can go for that. Actually, whatever spare time
whatever you find interesting.
Exactly. 2 participant raised hand. I don't know. 2 attendance raised hand. Rishika, somehow কিছু problem হচ্ছে, আমি ওকে unmute করতে পারছি না.
Sure. She can write it if she wants to ask questions.
If you can write it otherwise. Actually, in Sunday evening, what happens, there is a problem in the net. They are continuously WhatsApping that there is net problem, nothing can be done. But they can see it repeatedly, they can see it in YouTube. Because we have YouTube live, that's why whenever they want, they can see it, they can pause it, and they can follow it. That is
I have a whole lecture series captured in recording, but it's schools, universities property.
Obviously,
I taught this course.
Students.
Yes, I have a Zoom lecture series captured on different classes. Actually, this is the basic one, but that university's property I cannot share.
Exactly. So sometimes whenever we need, we can make contact with Shumana and some, at least you can go through some small portions.
Well, if you notice in my CV, I have done like weekly one series in Japan. I have done that several times here.
That's why I have read initially that you have designed so many courses and you have done all these courses. About this, I will talk to you later. What should be
and I do go through some theory and then go to the. Today I was just showing the analysis. It is good, but it will not stay with you unless you like. I think they will be appreciating more about the level of significance and that part, and that was kind of conceptual part. So I like to do that for every technique and then go to the data and show the analysis, because I cannot show analysis for every data. Everybody has a different data. I can show the overall theory and then go there. And it's kind of a 5 weeks module and all. I do it for, I did it for Clarkson for the physician assistant program, then physical therapy program. So they need to know the basic statistics. Like in 5 modules or so, they are easily doable.
Okay, one more. Students, please cooperate with us. We are going to give you the feedback link shortly. I'm going to give you the feedback link shortly, and in YouTube also, after minimizing this particular screen, I can share the feedback link in YouTube, because I am in this particular computer, I cannot actually minimize the screen. So I think for today it is enough, because you are actually talking for 2.5 hours continuously. And thanks a lot, Shumana. So
how you are putting the materials? Like, what is the way you are
Telegram group? We are we have created a Telegram group, and in that particular group, we are. I mean, I am sending or posting the material, whatever you, the resource persons, are providing. And for biostatistics also, I am also providing them some basic things of the UG level, because in the current syllabus, CBCS syllabus, a major portion of the biostatistics is being removed by UGC. That was a portion for last 25 years. All these biostatistics, I mean up to t-test, everything, correlation, regression, everything was there. But recently it has been removed. Only goodness of fit test is being kept. That's why I thought it is very much necessary for our.
It is, and it is actually kind of I will say neglected by a lot of cases. Categorical data is equally important as numerical data. Goodness of fit test, I just showed you for one variable. So there are tests for association, tests for independence. If you have 2 or 3, and they are extremely important.
That's why I thought, because UGC is always telling that we are actually bound or framed by the syllabus. But what we can do, we can model this kind of course where we can frame our own syllabus.
Absolutely.
We can design our certificate course from the institution. So this is a kind of initiation that I am making, that whether the students are really interested. If they get interest, then we can go for some online courses that are designed by us. small certificate courses, which are actually there will be no course fee or something like that. So I am planning for that actually.
Excellent.
So let's
Excellent
see,
idea.
let's hope actually 230 student is enough who are attending, and all from zoology background. I have not actually accommodated other life science branches or any other. Only zoology undergraduate students. So registered students were so many, but after that only 230 are following regularly.
Nice.
Okay, the quality is most important than quantity.
Definitely.
So it's a great thing. So I just like to request my other faculties of Department of Zoology to please keep their video on, so that I can, at the end of the session, I can introduce you with Shumana. Amrita, probably.
Ma'am, video on হচ্ছে।
I think all of them are on করা যাচ্ছে না তো। ও এক মিনিট। Co-host করো। SS নেই, Sushanta is not there, I think. Sushanta is not there, MM is there, okay. অমৃতার আবার সেই অন্ধকার হয়ে আছে সামনে, হ্যাঁ, yes, okay. So we are actually 5 faculties in our department. Me, the head of the department, as you all know. Then you can see Dr. Amrita Mukherjee. She is very enthusiastic, okay, and she is always with me. Ar edike royeche Dr. Monirujjaman, he is also a very, very brilliant scholar, and he has a very, very good research career, still continuing a lot of researches, and he has already gone through several projects and everything. Nice. And they are very cooperative. We have another 3 members. They are probably not here. Okay, so Shumana, আমার ছোটবেলার বন্ধু, তোদের সাথে জাস্ট ফর্মালি, ইনফর্মালি, এবার আমি আর অত ইংরেজি বলছি না, তো ইনফর্মাল আলাপ করেছিলাম। আর অমৃতা, জাস্ট চ্যাট বক্সে কি তোর ইয়েটা দেওয়া হয়েছে, ফিডব্যাক লিংক?
হ্যাঁ, তুই রেকর্ডিংটা ইউ ক্যান স্টপ, রাইট? উই ক্যান চ্যাট, ইউ ক্যান স্টপ দ্য রেকর্ডিং।
স্টপ রেকর্ডিং ওখান থেকে করো।
হ্যাঁ, আমি ফিডব্যাক লিংক দিয়েছি।
ঠিক আছে, আমি 1 সেকেন্ডের জন্য একটু মিনিমাইজ করছি, বিকজ আমাকে ইউটিউবে ফিডব্যাক লিংকটা দিতে হবে। ঠিক আছে, 1 সেকেন্ড। সো তুমি একটুখানি কথা বলো ওখানে।
সুমনা, প্রথমেই বলি, এক্সিলেন্ট একটা 2 আওয়ার সেশন,
2.5 ঘন্টা,
2.5 ঘন্টা একটা দারুণ সেশন।
তোকে দেখতে পাচ্ছি না সুজয়,
আমি ক্যামেরার সামনে নেই।
না, আমাদের ডেস্কটপে ওয়েবক্যামটা নেই, তারপরে আনছি।
I'm really thankful to you on behalf of participants, because that 2-hour or 2.5-hour session was really a needful thing for the long pending need for the students, because jeta papiya bollo ar ki amader je kono karonei hok, we are abide by the central agency to design our syllabus, and unfortunately last year the syllabus that was proposed by the University Grant Commission New Delhi actually removed that detailed part of the statistical application in the biological sample from the animal science.
আমাদের এখানে তো উল্টো হচ্ছে, আমাদের তো সমস্ত কোর্সে স্ট্যাটিস্টিক্স ঢোকাচ্ছে,
সেটা করতেই হবে,
and that is important,
at least আমাদের ইউনিভার্সিটিতে।
এটা ইম্পর্টেন্ট, আজকের দিনে স্ট্যাটিস্টিক্স বোধহয় সবাইকে অল্প বেশি।
অ্যাবসলিউটলি। এবং ইউএসএ তে এরকমও আলোচনা হচ্ছে যে হাই স্কুল লেভেল থেকেই এগুলো স্টার্ট করে, কারণ এই যে বিভিন্ন রকম যে প্লট করা এগুলো তো খুব ফান, এগুলো তো সমস্ত লিডিং নিউজপেপার ম্যাগাজিন সবাই করে।
It's not only for the science but for the social
understanding of the data, exactly.
Even literature যারা করছে তাদেরও কিন্তু স্ট্যাটিস্টিক্স দরকার হচ্ছে।
ঠিক কথা।
তো এখন এটা এই ধরনের কোর্স আশা করি আগামী দিনে আমরা আরো কিছু করতে পারবো।
একদম। আর এই ধরনের বেসিক লেভেল কোর্স থেকেই স্টুডেন্টসদের ইন্টারেস্ট গুলো গ্রো করতে থাকে। এবার ডেফিনেটলি এদের মধ্যে কেউ আরো শিখতে চাইবে, কেউ আরো জানতে চাইবে, কেউ ডেফিনেটলি খুব ভালোই এটাতে উপকৃত হবে, যে ইটস নিডেড ফর देयर রিসার্চ এন্ড ফর देयर আন্ডারস্ট্যান্ডিং অফ আদার সাবজেক্টস।
What happened with this pandemic situation, we have come into the era of this, at least in the India, because এটা ওয়েস্টার্ন ওয়ার্ল্ডে সব সময় হয়েছে অনলাইন কোর্সেস, আমাদের এখানে যেভাবে চালু ছিল না, but I think in near future we can go for that.
Absolutely.
So you can talk over here.
এখন কটা বাজে তোর সকালবেলায়? তো
12:10 আমার কোনো অসুবিধা নেই, আমার তো দিন চলছে আর কি, তোদেরই তো রাত হচ্ছে। আচ্ছা সবাই তো হাওয়া হয়ে গেল, মনির, অমৃতা, প্রণব।
না ওরা মাঝে মাঝে ওই সুজয় এলে আবার চলে যায়।
কেন করে
কে জানে, আমি জানি না, ওরা মাঝে মাঝে এরকম হাওয়া হয়ে যায়।
আমরা স্যারকে একটু ভয় পাই।
ও আচ্ছা স্যার, এটা আচ্ছা আচ্ছা,
আমি এত ভীতিজনক এটা জানতাম না।
আমিও জানতাম না।
তাও ভালো, ছেলে তো ভয় পায় না, অ্যাটলিস্ট কেউ ভয় পাচ্ছে।
সেই কেউ তো ভয় পাচ্ছে।
আচ্ছা পার্টিসিপেন্ট তোমাদের আমি I don't know everybody understand Bengali or not. Acha, we have already given the feedback link over in the chat box. You please collect it. And one more thing I have to say, that tomorrow's session may start from 5 p.m. or may start from 7 p.m. It will be only confirmed after getting confirmation from our resource person. We have 2 resource person tomorrow. You know, one from NIH US and another is from JDSI, Zoological Survey of India. They have still not confirmed that whether it will be from 5 or it will be from 7. I will obviously post it in our Telegram group. Okay, you know, I have previously mentioned that we can change the schedule according to the availability of our resource person. So we will post it in the Telegram group. So now you may leave. Officially the meeting is over, the class is over. Whatever question you have, you can email us so that we can send it to Professor Mondal, and whenever she has time she will obviously try to answer. Even we will obviously try to answer at our level best. Okay, so
you may stay back if you want to listen to our conversation. You can stay back as well.
না মানে যেটা হয়েছে ওদের কি হচ্ছে, আমরা তো খুব শর্ট টাইম করেছি। এবার তোর ক্লাসের আগে আমাদের ফেলতে হয়েছে যে ওদের বেসিক কিছু জানতে হবে, কারণ এখানে তো বিভিন্ন লেভেলে সিবিসিএস এর স্টুডেন্টরা রয়েছে, যারা অ্যাডভান্স লেভেলে তারা বেশ কিছুটা জানে আর অন্যরা কিছুই জানে না। এবার
they are asking good questions, that's what it says. Yeah,
এবার যেটা হয়েছে কি, তার ফলে এবার আমি যদি সব ক্লাস নিতে থাকি ওদের মনে হবে যে বায়োলজির ম্যাডাম কন্টিনিউয়াস স্ট্যাটিস্টিক্স এর প্রথম দিকটা, কারণ তোদের যে মেটেরিয়াল পাঠিয়েছি আমরা দীর্ঘ 2 বছর ওটা পাঠাচ্ছি, তাই জন্য ফান্ডামেন্টাল কিছু জিনিস করাতে পারি। কিন্তু আমি
দেখলাম সেটা
একটা ওয়ার্কশপের মধ্যে আমাকে তো যেহেতু স্ট্যাটিস্টিক্স পার, তাহলে তোর আগে আমাকে অন্তত অন্য দুজনকে আনতে হবে হু আর রিলেটেড টু স্ট্যাটিস্টিক্স, সবকটা আমি দিতে পারিনি। এবার তাতে কি হয়েছে, একটু ইয়েটা কমে গেছে, হোয়াট শুড আই সে, লিঙ্কটা কেটে গেছে, বুঝতে পেরেছিস? প্রধান যে কনসেপ্টটা অর্থাৎ কিনা নাল হাইপোথিসিস এবং অল্টারনেট হাইপোথিসিস should be given was not properly given in the goodness of fit class. That was the problem. And তোকে যেমন আমি একটা ইন্টারাপ্ট করে বলতে পারছি, since you are friend, then I cannot tell these things to other resource person.
মানে even in any basic statistics course like this, ইনফারেন্স শেখাতে 2 সপ্তাহ সময় লাগে, মানে এক সপ্তাহে 3টে করে ক্লাস, ঠিক আছে? কারণ শুধু তো পড়ানো না, ওরা কতটা বুঝছে, ইউ হ্যাভ টু টেস্ট দ্যাট, তার জন্য একটু প্রবলেম সলভ করাতে হয় আর কি। কাজেই সেটা করতে মিনিমাম 2 সপ্তাহ লাগে, শুধু সেই বেসিকটা করতে, মানে কোনো থিওরিটিক্যাল কোনো প্রুফ না, জাস্ট আর কি কি থিওরি আছে সেটা দিয়ে মানে কোনো ডেটা দিয়ে টেস্ট করা।
মানে আমরা কেন করছি, মানে আগেই এই যে ওদের এইটা ওরা কিছুতেই বুঝে উঠতে পারে না যে তোমার অ্যাজাম্পশনটা নিয়ে তোমাকে এগোতে হবে, কেন অ্যাজাম্পশনটা নিচ্ছ তুমি উইদাউট, ওরা খালি ভাবে করার পর আমি কেন করছি না, এই দুটোকে করতে অনেকটা সময় লাগে।
আর স্ট্যাটিস্টিক্স শুড গো সাইড বাই সাইড উইথ দ্য ডেটা অ্যানালিসিস। এটা সারা পৃথিবীর বেশিরভাগ অন্য ডিসিপ্লিনের লোকেদের ভুল ধারণা। I got the data, now let's do the analysis. Very wrong. You will not get what you are looking for or what is the real picture. You have to go side by side. Even এখন বলা হয় যে statistician should be involved in the study from the beginning to design the study. Designing the study is an art. It's not that easy. একটা কাজেই কিছু ডেটা পেলেই you should start analyzing, because you will see whether you are going in the right direction or not through that data.
অনেকটা করে ফেলার পর অ্যানালিসিস করে আমি বুঝলাম
করার নেই, তখন আর কিছু করার নেই,
অনেক ল্যাকুনি থেকে যায় ডেটা কালেকশন।
হ্যাঁ ঠিক কথা।
সেইটা একটা ভীষণ ইম্পর্টেন্ট। দেখা যাক মানে এই স্ট্যাটিস্টিক্সটাকে ওদের মধ্যে যারা ভালো স্টুডেন্ট বা হায়ার স্টাডিজ এর দিকে যাবে তাদের মধ্যে এটা ইনকালকেট করা খুব জরুরি। ওরা অনেক সময়
আর কোনো ভালো ধর zoologist যদি statistics জানে, it becomes very easy to continue the research in the postgraduate level. আমরা সেরকমই চাই ধর যখন PhD স্টুডেন্ট আসে তাদের মানে আমরা বলি যে ম্যাথ ব্যাকগ্রাউন্ড কেমন, which is I mean which we mean by like they have taken some basic statistics or math courses or not. That's very important. কারণ কোন পেপার এখন পড়লে সেখানে p ভ্যালু নেই এরকম কোন পেপার হয় না,
হবেই না মানে মিনিমাম
সুমনাকে আমি বলে রাখলাম আমাদের হয়তো নেক্সট উইকে আমাদের স্পেশাল পেপার মেল গুলো যাবে। আর আমার নিজের ব্যক্তিগতভাবে আমি যে ডিসিপ্লিন স্পেশাল পেপারটা চালাই দ্যাট ইজ সাইটোজেনেটিক্স এন্ড জিনোমিক্স, সেখানে 6টা বাচ্চা থাকে আর কি প্রত্যেকটা এই থার্ড সেমে আর কি অড সেমে একটা 6টা বাচ্চা থাকে, ওরাই আবার কন্টিনিউ করবে নেক্সট সেমেও। তো আমি আজকের ক্লাসে খুবই ইমপ্রেসড এবং এই যে তুই বললি যে এরকম শর্ট কোর্স হয় উইকে 3টে করে, তোর যদি কোনো আপত্তি না থাকে তাহলে আমার বাচ্চাদের জন্য যারা জয়েন করবে আমার ল্যাবে এবং দে উইল কন্টিনিউ ফর অ্যানাদার 1 ইয়ার, তো আমি কোনো একটা যেটা তোর কমফোর্টেবল সময় হবে বা পিরিয়ড লোড ওখানকার ক্লাস কম থাকবে ক্লার্কসনে এই সময় এরকম
না সেটা ওর সাথে জানতে হবে যে ধর একটা শর্ট কোর্স আমরা করাতে চাইলাম উইথ ইওর হেল্প, তাহলে আমাদের কি কি হবে মোডাস অপারেশন ইউনিভার্সিটি। আই এম নট টকিং অ্যাবাউট মাই ইনস্টিটিউট,
মানে অ্যাডমিনিস্ট্রেটিভ লেভেলে কোনো কমিউনিকেট করতে হবে কিনা।
হ্যাঁ ঠিক আছে, হ্যাঁ সেটা বলতে, কারণ আমাদের ইউনিভার্সিটিরও রুল ধর আমরা সামারে যেমন আমাদের তো অ্যাকচুয়ালি 9 মাসের কাজ, সামারে আমরা যা ইচ্ছা করতে পারি, আমরা যখনই যা ইচ্ছা করতে পারি, কিন্তু সামারে আর কি কিছু বলতে হবে না, কিন্তু বাকি যে 9 মাস সেটা আমাদের স্কুলের মানে এক্সট্রা কিছু করলে আর কি সেটা স্কুলকে জানাতে হবে, এই হচ্ছে ব্যাপার। সময় আমার করব সবই আমি, কিন্তু আই হ্যাভ টু লেট দেম which makes sense actually.
হ্যাঁ ডেফিনেটলি সেটাই
সেই মানে এগুলো ভালো হচ্ছে সবসময় ফেস টু ফেস, অনলাইন ইজ গুড কারণ এরকম সিচুয়েশনে এর থেকে ভালো কিছু হয় না, এন্ড অনলাইনে অনেককে একসঙ্গে পাওয়াও যায়, কিন্তু ফেস টু ফেস করলে বোঝা যায় স্টুডেন্টদের রিঅ্যাকশনটা কি হচ্ছে। ম্যাথের ক্ষেত্রে সেটা খুব ইম্পর্টেন্ট, মানে আমি একতরফা পড়িয়ে যেতে পারি।
লিখেছিস ওটা এক্স্যাক্টলি কিভাবে করেছিস?
ওটা ওই প্রত্যেক সপ্তাহে এরকম 2 ঘন্টা করে ক্লাস হতো আর কিন্তু ওটা পুরো হচ্ছে তো রিসার্চারদের জন্য বেসিক লেভেল ছিল।
আমি রিসার্চারদের রেসপেক্টেই জিজ্ঞেস করছি।
হ্যাঁ পুরো আমি ওই 2 মাস জাপানে ছিলাম শান্তনুর ওখানে, তখন ওর যে অ্যাডভাইজার উনি অর্গানাইজ করেছিলেন, মানে এরকম টপিক দিয়ে আর কি। তার আগে এই টপিকগুলো আমি এরকম স্লাইড বানাতাম, কিন্তু ওটা হচ্ছে একটা মানে একটা এর মধ্যে বসে বড় ঘরের মধ্যে বসে আমি বোর্ডে লিখছি, আমার টপিক আছে কিন্তু আমি বোর্ডেও লিখছি, সব করছি আর কি, এবং র্যান্ডম কোয়েশ্চেন্স আসছে আর ওইগুলো যেটা আমি এখানেও করি। এখানেও 5 সপ্তাহের ক্লাস আর কি ওই ফিজিশিয়ান অ্যাসিস্ট্যান্ট ফিজিক্যাল থেরাপিদের জন্য। আর এগুলো তো একসঙ্গে অনেকটা পড়ানো যায় না, কারণ যে পড়ছে তাকেও তো অ্যাবজর্ব
করতে হবে।
হ্যাঁ মানে প্রত্যেক উইকে একটা করে করলে মাচ বেটার। এবার তার সঙ্গে যেটা তুই বলেছিলি যে কিছু অ্যাসাইনমেন্ট দিতে হয়, তবে বোঝা যায় যে ওদের আন্ডারস্ট্যান্ডিংটা কত দূর গেল আর কি। ঠিক আছে, এবার এই সপ্তাহে এইটুকু পড়ালাম, পরের সপ্তাহে গিয়ে তার আগেরটা একটুখানি রিক্যাপ করে প্রশ্ন থাকলে আলোচনা করে পরের স্টেপে গেলাম, এইরকম ভাবে। মানে বলা যায় কাইন্ড অফ দ্য ওয়ার্কশপ অ্যাজ আ মডিউল, মানে এক একটা সপ্তাহে এক একটা মডিউল করে আর কি।
তুই যেহেতু প্রতি বছরই আসিস এবং বেশ অনেকটা সময় যখন নিয়ে আসিস, তখন তো ইউনিভার্সিটি চাইলে মানে ফিজিক্যালিও অ্যাপ্রোচ করতে
হয়। আগে থেকে প্ল্যান করে নিলে সবই করা যায়। ধর এটা তো ধর আমার একটা 2 ঘন্টার টাইম কমিটমেন্ট এট ওয়ান ক্লাস, ঠিক আছে। এবার একদিন আমি ওখানে গিয়ে পড়িয়ে এলাম, ধর এটা 3টে মডিউলও মানে হোয়াট এভার, মানে এগুলো আগে থেকে প্ল্যান করতে হবে আর যদি করার হয় কোনো অসুবিধাই নেই, করাটা কোনো ব্যাপারই।
ঠিক আছে। আর আমরা ওই শান্তনুকে আর তোকে কিন্তু ওই ইন্টারন্যাশনাল ওয়েবিনারের জন্য তুই তোর বিগ ডেটা
আগে বলে রাখ, শান্তনুকে আগে বলে রাখ।
আজকেই খেয়ে দিয়ে উঠে মেলটা করে রাখছি শান্তনুকে, ঠিক আছে। এবার কয়েকটা ও যে ডেট বলবে সেই মতো আমরা ফিক্স করে নেবো।
এটা কবে হবে? এটা হবে
কবে হবে বলতে সেটা হচ্ছে যেহেতু আমাদের মানে ইন্টারন্যাশনাল করব, সুতরাং প্রত্যেকটার মধ্যে একটা করে মানে 4টে থেকে 5টা করার ইচ্ছা আছে, ঠিক আছে। এবার সুজয় একজনকে ফিক্স করেছে, ওর নাম কি
অ্যাঙ্কে হুয়েল, ইমরি থেকে
একজন করা হয়েছে। এবার তার কাজটার সাথে মানে ওই একসঙ্গে মানে ওই টাইমটা কবে বলেছে ও?
অ্যাঙ্কে আমার নাম কিছু বলেনি, হয়তো নেক্সট উইকের এন্ডের দিকে উইকেন্ডে হবে হয়তো।
ওর কাজটা মানে ওরও বায়োলজিক্যাল ওয়ার্ক, ঠিক আছে, শান্তনুরও বায়োলজিক্যাল ওয়ার্ক। ওকে, তো ন্যাচারালি ওটা যদি
অ্যাঙ্কে ইজ আ জেনেটিক এপিডেমিওলজিস্ট, ওই এয়ার পলিউশনের সাথে জেনেটিক আর্কিটেকচার, জিনোমিক্স এইগুলো নিয়ে।
আচ্ছা আচ্ছা, আমাদের ওই লিংকগুলো পাঠাস, যদি সময় হয় শুনবো।
হ্যাঁ, কয়েকটা টেন্টেটিভ ডেটও পাঠিয়ে দিচ্ছি শান্তনুকে মেল করে ইউনিভার্সিটি অফ ক্যালকাটার সঙ্গে, তাহলে তার মধ্যে থেকে ও যদি একটা সিলেক্ট করে নেয় তারপরে না ফিউজ করছি। আর যেহেতু অনলাইন, ফিউজ না হলেও অসুবিধা নেই, উই ক্যান অ্যারেঞ্জ ইট ইন সেপারেট ডেজ। বুঝতে পেরেছি, সেটা পুরোটাই স্পিকারের কনভিনিয়েন্স অনুযায়ী আমরা করব। কিন্তু নেক্সট উইক থেকে, মানে এই উইকটা এই প্রোগ্রামটা শেষ হয়ে যাচ্ছে আমার স্যাটারডে, নেক্সট দুটো উইকের মধ্যে উই আর থিঙ্কিং অর উই আর প্ল্যানিং ফর অ্যাট লিস্ট 4 or 5 ইন্টারন্যাশনাল ওয়েবিনার্স, বাট ইচ ওয়ান ডে ইচ, মানে একদিনে দুজন স্পিকার 1 hour 1 hour। কারণ আমরা দেখেছি
একটা রিসার্চ টক, বেসিক্যালি ইটস লাইক আ রিসার্চ টক, যেরকম
ফ্যাকাল্টিজ এন্ড রিসার্চার্স। স্টুডেন্ট যদি এমনি মানে শুনতে চায় তাদের ব্যাপার, এটা যেমন আমি পুরোটাই স্টুডেন্টদের নিয়েই চিন্তা করে করেছি, ঠিক আছে? সেইটা একটা মেল করে মোটামুটি কথা বলে রাখছি, কথা তো বলে রেখেছিলাম, তারপরে এই প্রোগ্রামটা নিয়ে এত ইয়ে হয়ে গিয়ে আর মেল।
বুঝতে পেরেছি, মানে আমাদের ডেটটা ব্লক করে দিলে আর কোনো অসুবিধা নেই, তারপর ওটার অনুযায়ী আমরা অ্যারেঞ্জ করব।
সেমিস্টার শুরু হয়ে যাচ্ছে।
হ্যাঁ, মানে আমার তো পড়ানো থাকবে, শান্তনুর তো যেহেতু স্যাবাটিক্যাল পড়ানো নেই, কিন্তু হাজার রকম মিটিং টিটিং তারপরে কাজ আছে, কাজেই আগে থেকে বলে দিলে নো প্রবলেম।
ওকে।
অমৃতার
মনি, ওর শর্ট ফর্ম মনি, অনেক বড় নাম।
আচ্ছা আচ্ছা, মনি আর অমৃতা তো আমি নাম ধরেই ডাকছি, আমার এখানে সব ম্যাম ট্যাম সব চলে না, ডক্টর প্রফেসর কিচ্ছু চলে না, সব আমার আন্ডার গ্রাজুয়েট স্টুডেন্টরা আমাকে সুমনা সুমনা বলে চেঁচায়, এবং দ্যাটস দ্য রুল অ্যাকচুয়ালি।
ওই আর কি, মানে ওরা ভীষণ কোঅপারেট করে, মানে যথেষ্ট এনথুজিয়াস্টিক। এবার মানে সবাই তো আর সমানভাবে যে কোনো ডিপার্টমেন্টে কোঅপারেট করে না, দে আর ভেরি মাচ কোঅপারেটিভ আর কি। ইন স্পাইট অফ দিস কোভিড সিচুয়েশন, সবারই বাড়িতে অসম্ভব কাজ আছে, কারণ সবার বিগ ফ্যামিলি। ইন স্পাইট অফ দ্যাট টাইম বার করে রাত জেগে হোক, কাজের তো অনেকগুলো অ্যাসপেক্ট আছে প্রতিদিন।
ওরা পাপিয়ার ডিপার্টমেন্টের কলাম এক একজন আর কি ধরে রেখে।
বুঝতে পেরেছি, মানে পাপিয়ার হচ্ছে ডান বা এরকম বোঝা যাচ্ছে আর কি। হ্যাঁ,
থ্যাংক ইউ স্যার।
স্যারকে শুধু থ্যাংক ইউ করে, বোঝাই যাচ্ছে হেভি ভয় পায়।
এটাই আমাদের এখানে নিয়ম, বুঝতে পেরেছিস? মানে যেই তুমি একবার ইউনিভার্সিটিতে চলে গেলে তোমার তখন একটা ঘ্যাম হয়ে গেল, আর যত
আপনাকেও তো ম্যাডাম বলি।
না এইটা সেরকম না, ওই খানিকটা আছে আর কি, ওদের ভয় আছে, আমাকে তো ভয় পায় দেখে, অন্যরকম দেখতে, এলিয়েনের মতন দেখতে।
ওরা কি তোর কাছে পড়েছিল না, মানে কি কারণে এত ভয়
জানি না।
আচ্ছা,
যারা পড়েছিল তারাই ভয় পায় না, তার মধ্যে তো মানে কালকে এমন একটা ইনসিডেন্স হলো, মানে আমার ভীষণ রাগ হয়েছে। সেটা হচ্ছে যারা পড়ে গেছে তারাই আমার ধর ইউনিভার্সিটিতে জেনেটিক্স ডিপার্টমেন্টে, তারা বলার পর মানে যখন বলছে স্টুডেন্টরা কোয়েশ্চেন আনসার, বলছে কি কোয়েশ্চেন আনসার মানে আমরা অতটা নিতে পারবো না, এবং তারা অফ হয়ে গেল। মানে অদ্ভুত, অথচ তারা স্টুডেন্ট।
সেটা হয়তো না, দেখ ওরা সত্যিটাই বলেছে, এতটা হয়তো সত্যি নিতে পারছে না,
পারবে না, সেটা হতে পারে,
হতেই পারে। ট্রুথ বললে সেটাতে রাগ করারও কিছু নেই, সত্যি নিতে পারছে না, এনাফ।
এই আর কি চলছে। ঠিক আছে, অনেক গল্প হলো, আরেকদিন গল্প হবে। এনিওয়ে থ্যাঙ্কস আ লট। পরে আবার কিছু অফিশিয়াল কথা পরে বলবো।
নিশ্চয়ই নিশ্চয়ই, ঠিক আছে।
ওকে,
সবাইকে গুড নাইট। হ্যাঁ,
আমি কি তোর অ্যাসাইনমেন্ট একটা দুটো দিয়ে দেবো না তুই করে দিবি?
হ্যাঁ, দিয়ে দিতে পারিস। অ্যাকচুয়ালি এই যে লাস্ট যে দুটো প্রবলেম, ওই দুটোই অ্যাসাইনমেন্ট বলা যায়, ওরা তাহলে বোঝা যাবে যে ওরা ওই এটা ফলো করছে কিনা। মানে ডেটা তো সব আছে, আমি তো এক্সেল ফাইল পাঠিয়ে দিচ্ছি, ঠিক আছে? এক্সেল ফাইল দুটো পাঠাচ্ছি, কারণ মিনিট্যাব সবাই ওপেন করতে পারবে না, নাহলে মিনিট্যাবও পাঠাতাম, কিন্তু সবই রেজাল্ট এই স্লাইডসে আছে, সব যা যা টেকনিক ওরা যদি খুঁটিয়ে খুঁটিয়ে পড়ে বুঝতে পারবে, না পড়লে বুঝতে পারবে না। তাহলে এটাই অ্যাসাইনমেন্ট, ঠিক আছে? হ্যাঁ, ওই টি টেস্ট গুলো রান করাটাই অ্যাসাইনমেন্ট।
সার্টিফিকেট উইল বি বেসড অন দ্য অ্যাসাইনমেন্টস গিভেন ইচ এন্ড এভরি ডে। তো আজকে
দেখতে পাবি আনসারও লেখা আছে, কাজে ওরা যদি বুঝতে পারে আর যদি মাথা খাটায়, সব সব উত্তরও দেওয়া আছে ওখানে।
আচ্ছা, ওকে ওকে, চলো ঠিক আছে। তোদের
আচ্ছা
কি বলবো এখন, তো গুড নাইট বলা যাবে না, আমরা
তোদের গুড নাইট, ঠিক আছে?
গুড নাইট,
আচ্ছা,
থ্যাংক ইউ, বাই
বাই।
ওকে, তাহলে উইথ পারমিশন এন্ডিং।
ইয়েপ,
ওইটাতে রয়েছে। চললাম, টাটা।